Hello, everyone. We'll begin the session shortly, but in the meantime, if you want, you can scan the QR code on the screen and let us know what your main area of expertise is, and we'll start the presentations in 1 or 2 minutes. Hello, everyone, and welcome to Copernicus Marine meets the GMES in Africa community. I'm Marine Delorme, a training officer at Mercator Ocean International, and I'll be your host for today. We are very happy to organize this session, facilitated by the Joint Research Center of the European Commission, with the objective of bringing our communities together. Today is an opportunity to explore how Copernicus Marine data and services support and can support the GMES and Africa initiative, and more broadly, the work you are doing across the region. We'll share an overview of relevant products, practical use cases, and tools for accessing and visualizing data while leaving plenty of space to answer your questions. So I see that some of you have already answered the Slido, but we can have a look at this a bit later. And I'll just share some guidelines before we begin. So let me just start sharing my screen again. Okay. So before we really get started, let's quickly run through a few simple rules so that you can get the most out of today's webinar. So if you'd like to ask a question to our speakers, you can use Slido. You can join either by clicking on the link that was shared in the chat earlier, or by scanning the QR code that you see on the screen right now. Once you're in, you need to head to the Q&A tab that's circled in green here, and you can type your question over there. And of course, feel free to use the WebEx chat to say hello, to introduce yourself, and to connect with other participants. Today's agenda is quite packed with several speakers who will guide you through a comprehensive overview of the Copernicus Marine Service. They'll introduce the range of products available with a particular focus on those most relevant to your region and to your needs. We'll wrap up the morning session with speakers representing some consortia of the GMES and Africa program, as they introduce the services their teams have developed for the region, as well as the presentation of a decision tool to better target fisheries control, and that uses Copernicus marine data. This afternoon, we'll meet again and we'll pick up with a series of presentations on how to visualize, access, and download the data. We'll also highlight other useful resources available from the Copernicus Marine Service and Mercator Ocean International. And last but not least, we'll introduce the Opera project, which is dedicated to strengthening ocean prediction for regions of Africa. Throughout the day, we've scheduled several Q&A sessions with our speakers to make sure your questions are addressed. So please keep them coming and use the link that was shared in the chat, as I mentioned earlier. So now, without further ado, let's get started with our first presentation of the day. So we'll start with Aurore Biardo, who is a product officer at Mercator Ocean International, and who will do a general presentation of the Copernicus Marine Service. So Aurore, are you here?
Hello, thank you, Marine. Can you hear me well?
Yes, we can hear you well. I'll stop sharing my screen and you can start whenever you're ready.
I'm going to share mine. Okay. I hope you can see my screen well.
We can see your screen, but we don't see the presentation mode.
Okay, I just go to try again, sorry. Is it okay now?
No, we still see the PowerPoint interface.
Okay. Let's try. And now?
Yeah, we can see the presentation.
So thank you, Marine, and I'm going to introduce myself briefly. I'm Aurore Biardo. I work as a product owner at Mercator Ocean International. And I'm going to give you first a general overview of the Copernicus Marine Service, and then we'll dive a little bit more into the products catalog. So the Copernicus Marine Service is useful for accessing ocean data and tackling ocean challenges. The aim is to provide free and open marine data and services to support marine policies, but also blue economy or sciences. So it's very diverse. So about the Copernicus program in general, it has been launched a few years ago by the European Union. The objective of this program is to develop and implement an operational Earth observation program for Europe, but also for the global. It is split into 6 different services that you can see that are atmosphere, marine, land, climate change, emergency and security management. And each of them gives free and open access to Earth observation data based on in situ and satellite measures. And now we are going to focus more on the Copernicus Marine Service. So the data provided in the service can come from different sources that I just said that satellites, in situ, and models. This data can cover different temporal scales So multi-year for the data in the past, near real-time for the data around the present, and also forecasts for the data in the future. We go up to 10 days in the future in the Copernicus Marine. And it also covers several areas, geographical areas, such as global ocean, but also the Mediterranean Sea or the Iberian Biscay Ireland Seas that can be interesting today, and also different areas around Europe. About the sectors, so the data provided is used by all sectors of the blue economy. You can see here the 12 blue markets. So they are grouped by the 3 pillars of the United Nations Sustainable Development Goals that are environment, society, and economy. And on the web portal, you can browse through your use cases that will give you an overview of the usefulness of the Copernicus data for each of the blue markets. Then about the sources, so as I said, we provide satellite observation data as well as in situ observation data, sorry, that can come from different instruments. So we gather data from different satellite missions, from different networks and in situ platforms, such as Argo floats or gliders or other platforms, but also model data from 3D numerical representation of the ocean with different spatial resolution and different time ranges. And now about the data itself, we like to split it into 3 different categories that are the blue ocean, the white ocean, and the green ocean. So the blue ocean is about the physics parameters, for example, temperature, salinity, and so on. The white ocean is about sea ice. We will not focus on it today. And the green ocean is about biogeochemistry. So for example, chlorophyll, pH, and so on. And I will detail it a little bit more in this slide. So you have a focus on the blue ocean and the green ocean and the main variables we provide for each of those colors. So you can see on the blue ocean, as I said, the temperature, the salinity, but also the currents, the waves, the sea surface height, and also the winds. And for the green ocean, it's also very comprehensive, such as the primary production, the ocean color parameters, such as reflectance, turbidity, and so on. Also oxygen, zooplankton, microplankton, carbonate systems, and nutrients. And so now that we have all these data, how can you access it on the web portal? So there is a single access to the Copernicus Marine Service via the web portal. So it's you have the link on the slide, marine.copernicus.eu. So with a simple registration on the website, you can access the all free data store. All the data is harmonized through the same format, which is a netCDF format. And once you are on the Copernicus Marine web portal, several options are available. And the first one I will show you now is to click on the Ocean Products window. Just to give an overview, so in this Ocean Products catalog, you have access to more than 300 scientific qualified products. And as of today, there are more than 80,000 subscribers on the service. And all the data is open and free for all. So if you click on the Ocean Products section, you land on this Copernicus Marine Data Store, which is the product catalog. So what we call a product is actually a set of data of one or more data sets with all its descriptive information that we call metadata. And you can also on this catalog filter to find the data you need on areas, variables, time range, and so on. And then if you select a product, so if you are, for example, here I selected the Global Ocean Physics Analysis and Forecasts, which is a model. And if you select this product, you land on what we call a product sheet, which is a page for each product with all the description and the information you need about this product and some relevant links. So for example, here you have access to a link that provides different possibilities and protocols to actually download the data. You also have access to a user manual, which is a document in which you will find technical information about the product. You also can have access to information about data quality with the quality information document and the synthesis quality overview, and that assess how the products are validated in terms of data quality and metrics. You also have access to the DOI, which is useful to cite the products if you need, and also to a visualization tool on which you can see most of the products of the catalog in a map, in a very nice way. And so I will also present I will not go into details in the visualization tool, but just show you an overview. And then this afternoon you will have a demo from Leila to see how to use this viewer tool. So if you, it's another way to access to the data actually. If you go back to the main page, you have this section which is called Ocean Visualization. And then if you click on it, you have access to the different viewers. So there is a MyOcean Learn, MyOcean Lite, and MyOceanPro. The Learn and the Lite have basic functionalities, and the Pro offers more features, more advanced features. And just an overview of the Pro viewer. So this is an example of the visualization tool. You can explore the entire catalog on it. You can make plots. You can have some views for the polls. You can export image, videos, and data, and you can access to higher resolution graphs. But I will not detail it more now. And now I will present you some more services that are offered in the Copernicus Marine. So, for example, in the web portal, you can have access to an infographics, which is called Data in a Nutshell. This infographics provides clear reference to navigate, and it's a summary of the data available in the catalog. So we try to summarize with a blue, white, and green ocean, and to put all the variables that are available, to give some information, for example, with a geographical area, then temporal and spatial resolutions, and more information. So you can have access to it in the web portal as well by clicking on the Data in a Nutshell. The link is also provided in this slide. And the second service that can be useful also for you is a roadmap and transition information. So before each catalog update that we call entry in service, we provide detailed information of what is going to happen in the catalog. So you can have access to a roadmap infographics, which is summarizing what is going to happen up to 2028. But you can also have access to this that you can see on the right, which is the transition information, and you have access 2 months before each entry into service to detailed information, product by product, on what is going on very specifically. So you can search for a specific product. You can also subscribe to a RSS feed, to be informed on what is going on with the products you are interested in. So yeah, this is for the different services around the catalog. And now I'm going to present briefly also other parts of the Copernicus. So Copernicus Marine Service is, I would say, more than a data provider. It's also delivers a few things that can be of interest. So, for example, the Ocean State Report. The Ocean State Report is a yearly publication, and it provides a comprehensive state-of-the-art report on the current state and natural variations and ongoing changes in the ocean. There is also a summary which is available as a reference for the scientific community and the general public as well, to better understand the impacts of a changing ocean. So you can have access to this Ocean State Report by going also to the homepage of the Copernicus Marine Service and clicking on the second box. About the ocean monitoring indicators, so we are going also to present some indicators in detail a bit later, but this is just to have an overview. The Copernicus Marine Service also produces what we call ocean monitoring indicators that are free downloadable datasets and trends covering the past 25 to 30 years. And these are key variables that can be used to track the ocean vital health signs and changes in line with climate change mainly. And they can be used by either decision makers, either institutions, NGOs, or the general public as well. You can also have access to this catalog in the main catalog that I showed earlier. And so you also have the link in here. Those are two examples of OMIs just to show you that they can have they can take the form of a map or some trends or charts. It can be different depending on the topics, but we will focus on it later. Finally, so you will find on the website if you need a strong user support through multiple features. So you can have access to many e-learning material and tutorial videos to guide the users to access and download the data. So I encourage you to go and see that. There is also a chat offering support with a dedicated team and also an AI tool to answer your needs. And also there are a big article database with more than 120 articles answering most users' needs. So if you have an issue, it's very possible that an article has been written on it. And there are also more than 300 use cases online, which you can have access to see how the data is used and some applications. So yeah, I fully encourage you to visit the user corner and to have a complete view of the info and supporting tools at your disposal. And finally, about the user feedback. So this slide was just to say that the Copernicus Marine data is user-driven. So we continuously collect user feedback across different communities, such as different groups that we have, different surveys and questionnaires, different workshops and events, and so on. Then we centralize and compile all this feedback. We analyze it and we evaluate it with scientific groups. And then we see how to integrate and implement improvements of the service. Yeah, that is a full user-driven service. And that's all for this presentation. I will stop the sharing. I hope that was clear for you.
Thank you very much,
yeah,
Aurore.
Thank you.
So I will start sharing my screen quickly as well. So we'll take any questions related to this general presentation of the service in just a few minutes. Before that, we will have another presentation from 3 colleagues of Mercator Ocean. And we'll take a closer look at a selection of products and indicators that have been identified as particularly relevant for the African region. And so this section is divided into 3 parts. Aurore will start again with a short introduction to the topic and highlight a few key ocean products. Then Rosemary Souza will present a set of ocean monitoring indicators. And finally, Sarah Albern will close this section with a focus on zooplankton and micronecton biomass fields from the CPODIM LMTL model. So Aurore, if you want to start sharing your screen again, I guess.
Yes.
And the floor is yours.
And just tell me if it's okay. I will share full screen. Is it okay?
Yeah.
Okay,
Yes,
perfect.
it's okay.
So I will start again and then leave the floor to my colleagues. So about selected products of interest for Africa. So just a few information to introduce the engagement with marine data community in Africa. So as of last year, there were more than 3,000 registered users in Africa in the Copernicus Marine Service. Most of them come from universities, but also the public sector or private companies or others. And so we ask the user the main markets that they use the data for. And the main markets are environment and society, such as ocean health, marine conservation and biodiversity, climate and adaptation, and also extremes, hazards, and safety. Those are also statistics from last year about the countries in Africa with the most, the higher number of registered users. So there are a lot of users in South Africa, but also in North Africa, for example, Morocco, Algeria, Egypt, and Tunisia, and also all the countries, all the different countries in Africa that you can see here on this graph, such as Nigeria, Ghana, Kenya, Mozambique, and so on. So it's spread around the whole continent. And then I will present the top products that are used now in Africa by numbers of data users. So I will present you 4 models products. And after we will focus on indicators and biogeochemical useful products. So the first one is the most used for users in Africa, but also in all other continents. It's a global ocean physics analysis and forecast. So it's a model with a resolution of 1/12 of a degree, and it provides daily and monthly data about temperature, salinity, currents, sea level, and mixed layer depths in 3D, so from the top to the bottom of the ocean. And it also provides hourly mean surface fields for sea level heights and also temperature and currents. These products go to up to 10 days in the future for the forecast, and it goes up to 2 years in the past, but it's a sliding window. So 2 years in the past and 10 days in the future. The second product is data in the past. So it's global ocean physics reanalysis. It's the equivalent of the previous one, but in the past. So it's also 1/12 of a degree horizontal resolution with 50 vertical levels. And it's a reanalysis covering the altimetry from 1993 to nowadays. So it also includes daily and monthly mean files for temperature, salinity, currents, the main parameters, the same parameters as the product before, and from the top to the bottom as well. And in this model, observations are assimilated. For example, satellite data is assimilated to improve the sea level and sea surface temperature. In situ data is assimilated for temperature and salinity as well. So this model uses assimilation as a quality quality and also for the correction of the data of the model. Another product that is quite different is global total currents at the surface and at 15 meters depth. So this one is a product only for seawater velocity, as you can see in the picture. It can also be very useful for you maybe. So it's not a 3D product. There are two levels, the surface and 15-meter depth. You can have access to global total velocity field with Ekman and geostrophic currents. And the grid is 1/4 of a degree. And hourly, daily, and monthly means are available in this product. And finally, the fourth product I wanted to show you now is global ocean waves analysis and forecast that can be very useful as well for you. So it's a model as the first one, but mainly focused on waves. So the resolution is 1/12 of a degree, and you can have access to a forecast up to 10 days in the future as well for ocean sea surface waves. So the parameters which you can have access to are significant wave height, the period, the direction, the Stokes drifts, etc. So yeah, I think that's all for the main products and the main models you can that are used by a number of users in Africa. And I just wanted to have a few words on the latest key evolutions. So 2 days ago, we had a new catalog update with new products. So I wanted to show you some of them. The first ones concern the blue ocean. Starting from this week, you have now access to a new coastal bathymetry, which is derived from satellite observation from Sentinel-2 satellite optical imagery with a horizontal resolution of 100 meters. So this new high resolution bathymetry is only for the coastal zone, but for the global ocean. So it can be very interesting for mapping the coastal areas and for having more accurate models and forecasts. This product can be used for accurate coastal planning, but also for hazard risk management and so on. So this is a key new product for this year. I wanted also to tell you about the sea level improvements. So there is a new technology which is added recently, which is a wide swath altimetry observation from the new satellite, which is called SWOT. So high resolution data on surface water is available as well, on sea surface height, sea level anomaly, seawater velocity, etc. And it will allow as well to have more accurate model and forecasts. And the third product I wanted to tell you about is about the green ocean. So it's about the biogeochemical data. It's a new product for sargassum. So it's an index for floating sargassum algae detection, which is also derived from satellite observation and which allows an early detection of massive sargassum blooms. So you can see it on the screenshot. You can see this index map on the, of course, on only the zone on which you can find sargassum. So you can have access to those new products on the web portal. So don't hesitate to go and have a look at those new products and also at the roadmap section if you want to know more about the latest evolution of the service. And now I'm gonna give the floor to Rosemary. If you're online, I will keep sharing my screen because it's only a few slides, but if you want to take the floor.
Yes. Thank you, Aurore. Can you hear me well?
Yes.
Yes, okay. Welcome everybody to this webinar. I am Rosemary Sosa and I work at MarCOSIO International. Today, I am here to talk to you about ocean monitoring indicators or OMIs. These indicators help us understand how the ocean is changing under climate pressure. So Copernicus Marine Service had put in place a framework on ocean indicators. And in this slide is just an example where you can access online. You have also here the link to the ocean indicators, which is provide information, for example, on team ocean circulation, ocean climate, ocean variability and extreme, and ocean health, where you will find a set of different type of indicator for global scale and also regional scale. Today, I will briefly show 4 OMIs that are particularly relevant for Africa. Next slide. Okay, thank you. In the first panel is the Atlantic Meridional Overturner Circulation, AMOC, at 26 North. The AMOC at 26 North plays a key role regulating Atlantic temperature, which means that any change in this strange can influence West Africa coast, affecting drought patterns, winds, currents, and even marine productivity. The second indicator in the first panel is the northward heat transport. Ocean heat transport across bases modulates regional climate. Sorry. As a consequence, it influences temperature extreme, monsoon behavior, and circulation patterns affecting both sides of Africa. And in the second panel, show the next indicator is the North Atlantic eutrophication. This indicator is important because eutrophication drives change in productivity, which can impact ecosystem and fisheries that connect to Northwest and West Africa. And the final indicator in the, in the second panel is the global mean sea level. Global mean sea level is a critical climate indicator because it directly determines the vulnerability of Africa coast, leading to increased erosion, flooding, and coastal salinization. And well, to summarize, these OMIs help us link large-scale ocean change to regional impact in Africa. Also, they provide essential information for climate monitoring, also coastal risk assessment, and the management of marine resources. And well, that's all for my side, and thank you. And Sarah, the floor is yours.
Hi, can you hear me?
Yes, thank you.
Good. Good morning. My name is Sarah Alberne. I'm a postdoctoral researcher. Sorry, did you say something, Aurore?
No.
Okay, sorry. At MarCOSIO, and I'm going to talk about the zooplankton and microplankton biomass fields that you can find on Copernicus, derived from the model CPODIM LMTL. So for those who are not familiar with zooplankton and microplankton yet, we'll have a look at the simplified trophic chain of the ocean that you can see on the slide in 4 levels. So the first level is the phytoplankton. So it's the plant-like plankton. So it's composed of several microalgae, and they are eaten by what we call zooplankton. So it's the animal-like plankton. They are organisms ranging from a few micrometers to a few centimeters. They are the prey of the micronecton. So micronecton is a group of organisms between 2 to 20 centimeters. They are composed of several species such as cephalopods, crustaceans, small fish, etc. And they are the main prey of the marine top predators like tuna, for instance. Next slide, please. And so what we call low and mid trophic levels are respectively the zooplankton and the micronecton. So these organisms are really important, first because, not yet, thank you.
Sorry.
First because they are located at the intermediate level of the oceanic trophic chain, so they sustain all of the higher trophic levels, some of which are harvested economically by fisheries. And the other main point about these organisms are their migratory behavior, which is really important. They perform what we call diurnal vertical migrations. So they migrate every day between the surface of the ocean and the deep ocean. So they stay during the day at depths where there is no light to hide from predators. And they go back at the surface during the night to feed. And they perform these migrations every day. And this way they export and sequestrate carbon from the atmospheric carbon to the deep ocean. And so they really help us regulating climate. So now you know everything about zooplankton and micronecton. Let's have a look at the related Copernicus project. Next slide, please. So we have a model called, so it's a numerical model called CPODIM LMTL for low and mid trophic levels. Which enables the computation of 2D fields of biomass of zooplankton and micronecton based on environmental data. And that's what you will find on the related projects in Copernicus. You will find 2D fields of the biomass of zooplankton, 2D fields of the biomass of 6 different functional groups of micronecton. So 6 groups because there is different migratory behavior. Some organisms migrate more or less deep, so you have different behaviors. And you will also find in the project the forcing data, so the environmental data that have been used by the model CPODIM to compute the biomass fields. So you have, for instance, the net primary production, which is basically the production of phytoplankton. You will have the euphotic depths, so the depths in the water column where there is no light anymore. You'll have the temperature, the currents. All of these fields have a spatial resolution of 1/12 of a degree, and they extend between 1998 and 2023 at a daily resolution. Next slide, please. And so build upon this modeling framework, we did a study that is an article in the Ocean State Report, where we used the environmental data of the product, so the forcing data of CPODIM, to build what we call biophysical provinces. So they are provinces that are homogeneous in terms of environmental data. And we observed that even if these provinces are only based on environmental data, they also gather homogeneous biomass and vertical structure of micronecton. And so for the Ocean State Report, we studied the evolution of these provinces in time. That's what you can see on the right-hand side of the slide. And the main outcome of this work are first the shrinking, so the reduction in size of the productive provinces, so the provinces that have a high density of net primary production and of micronecton. We observe the same for the polar region, so they are shrinking in time to the benefit of the equatorial and tropical provinces. So they extend in size, but they have weaker density in biology, so micronecton, etc. We also observe that all of the provinces are drifting poleward. And the related conclusion that linked to the African region is that the productive provinces of the Atlantic coast of Africa are shrinking. And so this could have influence on fisheries and on the social economic opportunities for the coastal countries of Africa. So that's one of the case studies that you can derive from this product. That's all for me. Thank you, Aurore.
Thank you, Sarah and Rosemary. I think that's all for us. I will stop sharing.
Thank you very much for these presentations. We've received a few questions, and so I will start sharing my screen so that you can also have a look at them at the same time. Okay. Okay, so you should see my screen now. So if you have any other question for Sarah, Aurore, and Rosemary, don't hesitate to go to the link that was shared in the chat and go to the Q&A section and you can type your questions here. So for now, we've received 3 questions. The first one, I think, is about data for Angola. So I don't know if, Aurore, you can answer this one.
Yes, so don't hesitate to go to the web portal, as I said, and to dive a little bit into the user corner. But you can also have a look at the visualization tool, and zoom on your zone and see which products are available. For Angola, I think it will only be the global product, so you can filter on global ocean and then see what is. It depends which data you want to, but we have a lot of different data for the global ocean, so don't hesitate to browse.
Okay, thank you very much. Then we have a question about the application of machine learning. So the question is, do you have options for those of us that are into the application of machine learning in coastal environments activity prediction? I'm into video-only machine learning and computer vision for nearshore wave predictions. I don't know if any of you has any answer to give regarding this topic.
Yeah, it's a very specific topic.
I know, yeah.
What I can advise you is contact the user support with the chat, for example, and ask your questions, and someone qualified can answer if it's possible to link you with someone or.
Yeah.
Yeah, I would advise to contact the user support for that.
Yeah, that's a great suggestion. So how you do this, for example, is if you go to the Copernicus Marine website, you click here on the bottom right, and then you can go to message and ask a question to someone. So you'll either talk to the AI agent who is able to answer actually a lot of questions and knows the catalog pretty well. And you can also talk to a real person from the user support team. So thank you for this answer. The third question that we have is, do you have a product for the phytoplankton and chlorophyll, like the NASA PACE? So I guess the answer to that is we have products for phytoplankton and chlorophyll. Something you can do is go to the catalog and filter by those variables, or you can also ask Blue, the user support team, for some help on selecting the product that you're interested in. But I don't know if, Aurore, you'd like to add anything to this?
No, I agree with you. There are a lot of products displaying phytoplankton and chlorophyll. The best is to browse into the catalog and to filter by variable in the green ocean.
Thank you very much. I guess we have more of a general question. I don't know if any of you three would be able to answer this one or would like to answer this one. In environmental monitoring, why is it important to record the exact date of predictions or observations? Is it something that any of you would like to answer?
I don't have a specific answer to this one.
Maybe I can say a few words. It really depends on what you mean by environmental monitoring, but in ocean modeling, we really need to have the exact dates, sometimes even the exact time, like the hour, to see if it's daytime, nighttime, to have more data to validate our model, to train the models, to understand the mechanisms behind. And the more precise and specific information we have, the better. It's always the case like that.
Thank you very much for your answer, Sarah. And the last question that we've received for now is, what are the main indices we should put into consideration to study coastal erosion in the Mediterranean? Sorry.
Maybe maybe you can complement, but I would say you can have a look at sea level rise in the Mediterranean, and you can also have a look into the ocean monitoring indicators that that we provide on the Mediterranean area specifically.
Yes, Aurore, I agree with you. You can look the OMIs, for example, the global sea level, or maybe yes, the global sea level. I think that is a good indicator for study this case.
Great. Thank you very much for your answers. We don't have any other pending question at the moment, so I think we'll end the... Oh, I see one coming through the chat. Oh, sorry, I'll just need to open it again. Oh, on a scale of accuracy, are the data you provide reliable? So the answer is yes, but Aurore, would you like to complement maybe?
Yeah, I can complement a little bit. So all the Copernicus marine data is go through a very big process of validation and quality assessment. So I will not detail it now, but you can have access for each of the product to a quality information document in which the way each variable is calculated is explained. And you can also have information on the metrics that are used to assess the quality of the data. You can also have access on the web portal to the product quality dashboard, on which you can see the quality of each of the variables for each of the area and so on. I hope that answers the question.
Thank you, Aurore. I see another question coming in the chat. What is the spatial resolution of Copernicus marine data, and can it be used for coastal fisheries? I think, Aurore, you've... I guess the spatial resolution varies depending on the product, but Aurore, if you want to say a few words on this.
Yeah, same. You have all the answers in the web portal. The resolution depends on what you want to look at, and of course it can be used for every topic. But I'm not sure. I didn't see the question. Sorry, I was not sure to understand it well.
I think it's just about what is the spatial resolution of the data, and can it be used for coastal fisheries?
Okay, so you can have access to, depending on the product, the resolution is not the same. So, and also depending on the variable. So you can have access to all this information by searching on the website or asking the user support if you need a very specific topic.
Okay, well,
maybe I can complement on. Oh, sorry.
Yeah, go ahead. Of course.
About the coastal fisheries aspects. So I guess you can use the environmental data that you have on Copernicus for the coastal fisheries. However, if you're interested in the praise of the species you want to fish, the MyConnected and zooplankton products are not everywhere available at a coastal scale. But at least you will be able to use the environmental forcings such as temperature, primary production, and so on.
Great, thank you. Leah, I can see that you've raised your hand. I don't know if...
Yes, I would like just to complement the question about the reliability of the data. That's just to reinforce, to complement Aurore, that if you go in the catalog and you check, you select one product, maybe we could go just to show them, yeah, thank you, Marine. So just the quick way to go, if you select just the first product, for example. And if you can look in the on the left, we have all the main documents, like for example the user manual, that's remain all the scientific methodology used to develop this product. And also we have quality information document. So there is all the methodology made and also the metrics as Aurore mentioned. So for each product we can verify the methodologies behind and also for the quality and metrics of this product. Just to complement how to check it if someone is curious to verify one specific product. We can listen you, Marine.
Yes, sorry, I forgot to unmute myself. So yeah, you just need to go to the catalog, click on the product you're interested in, and then you'll find these documents on the left. Okay, well, thank you very much. I think that's it for this Q&A session. And I guess we will just continue with our next...
I would have just one comment, if I
yeah,
may,
of course.
just a short one on the coastal applications. There's been some question on this. I know that there are a certain number of downscaling analysis in European waters using as boundary conditions the actual, let's say, lower resolution products. So my question is how CMEMS is foreseeing these the availability of these high resolution coastal results from these applications, and how they are envisioning eventually exporting these applications into some other areas than European waters, in particular in Africa. If you have any insight on this, I think it would be useful for this community.
Jean-Noël, you mean giving access to high resolution data to other regions than European ones?
Yeah, there are downscaling exercises. So you modeling the same type of variable like temperature, salinity, but in higher resolution coastal environment for specific applications like coastal fisheries, aquaculture, things like that. And are those tools are envisioned to be made available to a larger community outside of Europe? Because it's not only Africa, but also islands in the Pacific, for instance, would be very much interested in order to export not only data, but also the tools that are allowing this downscale exercise into a specific coastal environment.
Yeah, I think that's interesting. I think that's a topic that is discussed in the scientific advisory group of Copernicus. So I don't have the precise element now, but of course this is a topic that can be discussed in board of the scientific direction of Copernicus. Yes,
would be useful. Yeah,
Mhm.
thank you.
Okay, thank you very much for all these questions and the answers that you've shared with us. So I think we can now go to the next speaker. And I will start sharing my screen very quickly just to introduce our next speaker. So our next speaker is Lufuno Vengani from CSER, and he will be presenting the marine and coastal operations for Southern Africa and the Indian Ocean Service. So Lufuno, are you with us?
Good morning, everyone. Yes, I am here.
Yes, hi. I'll stop sharing my screen and you can start sharing yours whenever you're ready.
Okay, I'll try to start sharing now. Okay, getting there.
Take your time.
Okay, are you able to see my screen?
Yeah, but we don't see the presentation modes yet.
Yes, I've got the presentation mode now. Okay.
Yes, that's
okay.
perfect.
Good day, everyone. My name is Lufuno Vengani from the CSIR. I'll be presenting on behalf of Dr. Mary Smith. And the presentation is all about the MarCOSIO services that make use of the Copernicus Marine Services data. And just to give a brief overview about the MarCOSIO project, this is one of the 2 marine consortia within the GMES and Africa program. And the project has 12 partners, which are spread throughout Southern Africa and the Western Indian Ocean region, and currently led by the CSIR in South Africa. And you can see on the right there, there's a map showing the geographic spread of all the partners. And this project really has got 6 pillars, which include your capacity building, data access, and services, which is what we are going to focus on the services. We've got the coral bleaching tool or service, which is on the domain of coastal services, and then also the aquaculture tool, which is on the domain of fisheries and aquaculture. Starting with the coral bleaching tool, I hope you can all see my screen. This tool, you can access it using the URL shown on the screen, or also the QR code. And you can see on the tool that you've got different data sets that you can choose, starting from the SST, the anomalies, the hotspots, coral bleaching alerts, and the degrading week, and also the viewer. And also you can see on the right of the screen, you've got a plot which shows the time series data.
We just see, sorry to interrupt, we're seeing your presentation.
Is it not moving?
Yeah, were you sharing another screen? Yeah, because we were just seeing the overview slide, so I don't know if it was what you meant to share.
No. It was supposed to fly. Please let me just unshare and start again. I don't know what's.
That's okay. Don't worry.
Okay. Let me share again.
Technology is not also always on our side, sadly.
Apologies about this. To show the entire screen. Yes, this one. Okay. Is it showing now? Again?
So we're showing the slide that says project pillars.
Yes.
Okay, perfect.
And then when I scroll back, does it move?
Now yeah, it does.
Okay. Apologies about that. I don't know why it was not moving before. I even forgot where I was, but I think I was trying to show the project pillars, that the project has got 6 pillars, and it includes your capacity building, your data access, institutional frameworks and policy, and services, and we are going to focus only on services. And on the services, we've got services in multiple domains, which include your service, your fisheries and aquaculture. That's where we find the aquaculture service, and also the coastal service. That's where we find the coral bleaching service. And starting with the coral bleaching tool has a user interface, which you can find using the URL or the QR code shown in the screen. I hope now you can see my screen, and you can see that the tool has got tabs where you can access the data, and the map area where you can visualize and see the data, and also the time series data that is there. I'll say more on this as we move on. About coral bleaching, we know the importance of coral bleaching, though this is not my domain. My domain is on the software development side and remote sensing, but we all know that coral reefs are important for our livelihood, for tourism, and for shoreline protection. And there are threats to these coral reefs, which includes your sea surface temperature rise, ocean acidification, and so forth. And then this bleaching on coral reefs, it occurs when they are stressed by the change in the environment, and then this makes them to lose their vibrant color. And coral bleaching itself is a threat to security and ecosystem services. So this means that we really need to continue monitoring coral bleaching because of their importance. So the way what we do to monitor coral bleaching, we use data derived from the Copernicus Marine Services data. We use the OCR sea surface temperature data, and from this we are able to derive other products. The product that we use is a level 4 daily product, which is gap-free at 5-kilometer resolution. And this provides information on potential alerts, immediate and accumulated thermal stress. And of course, the methodology that we use is similar to that used by the Coral Reef Watch, but in this case, we are using the OCR SST data and the regional climatologist data that we have. You can see that on the right, we've got the SST data, the anomalies that we generate. From that, we also generate the hotspots, the alert, the bleaching alert, and the degree heating week. And on the other hand, we've got your virtual stations. These virtual stations are latitude and longitude points where we collect some of the data and we store it so that we can have historical information for the past 12 months. But in the database, it's not necessarily 12 months, but on the viewer, we only show the past 12 months and the current date, up to the current date of the data that we have. And you can also select you can also select the virtual station that you want to visualize, and then it will change accordingly. Also, you can also change the range that you want, either 2 weeks or 6 months, and also 12 months. On the other side of things, this is what I mainly do. The ingestion of the data is automated thanks to the Copernicus Marine API, which is provided. And you can see on the flow there that we get the OCR data together with the climatologists, and then we create this data, and then we store some of them to databases and our web mapping server, and the data is then visualized onto the coral bleaching service. Besides that, we've got our partners who have got a dashboard which shows in-situ data. So this in-situ data is collected and then is visualized on their browser there, which you can see using the URL or the QR code which is provided. And they also publish a coral bleaching alerts bulletin every 2 weeks from January to May, which is their peak time. Moving to the aquaculture support, you can see on the screen the more or less how it looks like. We've got a date selection. We've got tabs for visualizing the data that we use there. We use various products from UMEDSAT and from Copernicus Marine Data Services. And the URL for the service can be shown there on the link below, or also using the QR code. This graphic that you're showing which you are seeing on the screen, it shows what has been happening with the marine aquaculture sector. It has been growing, but we can see that in Africa, it's not growing as much as it is growing globally. So there is a need for this kind of service in order to safeguard the existing aquaculture operations that are there in the region, and also to promote the growth of the sector also. Okay. So what we do to support this, we have got the chlorophyll-a products that we generate to show harmful algal blooms, and also we have the sea surface temperature data that we use to monitor against marine heat waves and also the food web disruption and mortalities. So the satellite products that we use for the aquaculture service, as I said before, is the near real-time products from HUMIDSAT data store. This includes your chlorophyll-a product, your SST, which is got AM and PM, and also we've got the gradients that we generate, which help us in terms of the fisheries, because this is where your fishes congregate, and this is what this can be used to show where the potential fishing zones. But unfortunately, the near real-time data has got clouds in it, so it will have gaps. So the gap-free product from CMEMS is very useful because it covers where there are gaps, though it may be a day or two behind, but at least the data is there to cover the gaps which are there in the near real-time data. And for this, we use the globe color, which is a 4-kilometer resolution data, and the austere SST data, of course, for the SST and for the SST anomalies. And the picture that you see there is the globe color chlorophyll, which covers the entire region. Also, I think it even exceeds the region from Gabon up all the way to Kenya. And this is gap-free. And then also you will see that it also shows data in the large African lakes. So this is not necessarily what we do is not necessarily ends in services, but we also do training and also reach out to users. We can see on the picture there, Mari in the middle there, with some of the participants of the training that have been conducted, where users are equipped with the remote sensing and also on how to use the data. And this is feedback from one of the users where they were telling us the importance of having this data on their site. And
I'm sorry,
how is it? Yes.
I think your screen is stuck again. On
Apologies about that.
That's
So
okay.
from which
we see at the moment we see the slide that says aquaculture service satellite derived products.
Okay. Okay. Not sure what's going on. I'll stop sharing again and share again. I don't know what's going on. Apologies about this technology. Let me share again.
Yeah, no problem.
And unfortunately, I had already reached the end of the the presentation with all these.
That's okay. You can take a few more minutes too. Yeah.
Yes. Okay. So, what do you see now? Is it moving?
No, for now we just. Oh, I think no. We just
Okay.
see the same satellite derived products slide. Sadly.
Yes. I want to go back in time.
Oh, now it's moving. We
Yes.
see the environmental information one.
Yes. Did you see this one?
I don't think we did.
Okay. Let me go back. I think maybe you show this one.
Background and overview. Yeah. That's okay. I'll let you get back to it.
Okay. Apologies about this. I don't know why the slide is not moving on my side. I wish I just had a PDF of this and just show it from the PDF. I think this is where it was stuck, right? And was in time.
Now we see the slide with the QR code. I don't know if it's the one you're meant to share. Okay.
I'd already moved on. So here I was talking about the viewer, the aquaculture support service viewer, showing how it looks like. It's what is it? Describing the use that it has got date selection. You can also select multiple data sets on it, and also the URL which you can use to access the viewer, the tool. I see. Is it moving now? Am I on the next slide?
No, you're not. Oh, now you're on background and overview.
Okay. So on this slide here, I was saying that globally, the aquaculture sector is growing, and there's a need for us to, but in Africa, the sector is not growing as much. So there is a need for us to safeguard the existing aquaculture operations and also promote new growth using data. Same slide, I'll pass this one. Okay. And then when the focus on safeguarding the existing operations is done through the chlorophyll-a data and also the sea surface temperature data, which is used to monitor marine heat waves and associated acidification, deoxygenation. Okay, so this is done using near real-time data sets from a UMETSA data store, and this data is 1 kilometer from in resolution from Sentinel-3 data. It's a what is it? MARI developed the model here for chlorophyll-a, but the SST we use SSTs, and we also generate the gradients which we use to see where the fish could be congregating. This the gradients are normally used for fisheries because it shows the potential fishing zones. And this is done by checking the gradient where the temperature varies by more than 0.5 degrees. And we also have the gap-free data from CMES. I hear now we are calling it Copernicus Marine Services. This is data which is available 2 days, sometime 1 day or 2 days after the near real-time data. We use the globe color, which is a 4-kilometer special resolution data set, and also the Ostia level 4 SST, similar to the coral bleaching, and then the anomalies also. And the globe color, that is how it looks like. Is it showing? Is it changing?
Yes, now we see the gap-free products.
Okay, now the grape-free. Okay, the slides are slower than myself. I've already mentioned this one about the gap-free products, which are really essential to cover the gaps because of the clouds that we may be having on the near real-time data. And then the next slide, I'm showing a picture of the level 4 globe color. I don't know if it's showing on your side. The internet is, I hope, is it showing?
Not for now, I don't think.
Okay, apologies. But let me just conclude this presentation by saying that we've got the gap-free products, which are really important in covering up the gaps which are from the near real-time data products. Let me conclude by that. I think I've already said most of the things that I wanted to say about this. So yeah, but this data is really essential. We also received some feedback from users on the importance of this data for their work in aquaculture operations. So let me stop here and thank you, everyone.
Well, thank you very much, and sorry the technology wasn't on your side today, but we'll have a Q&A session in just a few minutes, so you can answer all the questions that were asked by participants during your presentation at that time, and give any more precisions that you'd like to share when we do the Q&A.
Thank you.
Okay, great. Thank you very much. So we'll continue with the next speaker, who is Daniel Kouarchi from the University of Ghana. He's an Earth observation officer and is going to present the marine and coastal areas management of North and West Africa. And a specific use of the data. I don't know if Daniel, you're here.
Can you all hear me?
Yes, we can hear you. Hi.
Perfect. I'm quickly going to share my screen.
Yeah. Hopefully PowerPoint cooperates on your side.
Hopefully. There's a few seconds.
So we see your screen.
All right, then I'm going to switch to the presentation mode then.
Mm-hmm.
All right, perfect. I believe you can all see my screen now.
Yeah, it's perfect.
I'm just going to do a quick test, just to change the slide to see if it changes at your end too.
Yeah, we see your slide changing.
All right, perfect. So
You're on the second one
I'm
now,
going
I
to
think.
begin.
Yeah, go ahead.
So I just switched to the first one now. Okay, perfect. Good morning, everyone. My name is Daniel Pashi, and I'm with the University of Ghana. Today I'll be presenting on behalf of Dr. Kwame, who is the project coordinator for the MarCNoWA project. So MarCNoWA is actually a consultant name for marine and coastal resource management for North and West Africa. This particular project is one of the projects under the GMES program, where our focus is on utilizing Earth observation data to develop solutions to address issues within the fisheries and coastal ecosystem and stuff like that. Currently, we run this project across 18 countries. That's from Nigeria to Egypt. So within the North and West Africa region. For this particular project, it's not just we running it, we're actually running it in conjunction with other institutions within the region, like Ghana Meteorological Agency, Europe in Benin, and also Neoma in Nigeria. I'm going to quickly, So for this particular presentation, I'm just going to focus on the services that we provide under the project. We have 6 main services: the monitoring and forecasting ocean variables, regional marine weather forecast, fisheries, oil spill, coastal ecosystem, monitoring coastal vulnerability. But I'm going to focus on the services that are actually powered by the Copernicus Marine data, which are the regional marine weather forecast, fisheries, resource management, and oil spill monitoring. So where does Copernicus Marine actually fit into our key services that we provide? Most of the services that we provide, we make use of data set coming from the Copernicus Marine, like waves, currents, SSD. These data sets are then pushed or processed to generate information that are disseminated to users through mobile apps, web portals, and then our main users, our end users, are mostly fisheries, people in the fishery industry, the marine security, that's the Navy, the coastal managers, and fisheries agencies as well. My first use case I want to talk about is the safety at sea advisories that are for small scale fishers. So with this particular service, we make use of the global ocean wave analysis and forecast data set with the objective of supporting fishermen, because we realize that most fishermen, when they go to sea to get fish for us to enjoy on our dinner table, they do this at the risk of their lives. And what we do is that we take the same data, process them, and generate wave index. Before the introduction of this service, we had about 168 accidents at sea with 52 deaths occurring. But once we were able to introduce this service, we've seen a reduction in the number of deaths and accidents at sea and the number of canoes that are destroyed at sea. We currently have about more than 17,000 people that are making use of this particular service, and these are mostly fishermen, our artisanal fishermen who will go to sea. So this is the workflow to show what actually happens once we get the data. What we do is that everything is automated in terms of like the data accessibility. We actually use the API that SEMS provide. So we automate the process to get the global wave analysis and forecast data set. Once we have this data set, what we do is that we process and generate a safety index where it's just categorized into three portions. One, which is green, two, rough, and three, dangerous. Once we generate the safety index, we create an advisory message that we send out to the local fishermen. And with feedback from users, we now translate this advisory message into their local languages. And beyond that, we create an audio and also send this message to a USSD code, because we realized that most of the fishermen at that time, at the onset of this particular project, they didn't have smartphones to be able to access. And some of them were not educated, so they were not able to understand the complex information. So we had to present this information in ways that they can easily understand. So we send this information out to them on a USSD code without, which will require them to access it without internet. Mobile app, we develop a mobile app, and now we're currently sending this information or working to send this information through WhatsApp. For those who don't have mobile phones, actually can also access this information at their landing sites, where focal points and hoist flags to communicate this advisory to them. And this is a template of that WhatsApp advisory message that we are sending out. It's just a very simple two-line message that is sent to them. That is sent out to them. Basically, we make sure that we keep the information as easy for them to be able to read on their mobile phone, and we also include screenshots of maps and also audio clips in their local languages. So this is a sample. This is a sample advisory message in my local dialect in Ghana. So this is what we say in Planotibia, which is the ocean state for that particular day. So we just show an emoji for them. Once they see the emoji, because some of them can't read the text, so once they see the emojis and the color of it, they are able to get the information. And based on that, they could then take a decision on what to do, whether to proceed or kind of like call off their expedition for that day. And this is an example of the image that we also send out to them. Those who can read this, once they see an image like this, they can be able to plan their expedition, whether to go to sea or not. We also have an audio file here. Sorry. Yes, this. An audio file in English and French. So French-speaking people can also
We don't hear the sound. I think you would need to share the sound of your computer for us to hear it.
Oh.
So if you click on share on the right, you can tick a box that says include the computer sound, I think, when you start sharing your screen.
Okay, that means I would have to stop sharing the screen to do that. Can you please still see my screen?
We can still see your screen, yes.
Okay.
I think you need to stop sharing completely and then start again.
Okay. Unfortunately, I'm not able to use stop sharing because it still says connected. But I can proceed once I'm sure this presentation will be made available to the users, if that's fine with you.
Yes, it will, and we can listen to the messages later on as well if you want to do it later. That's fine.
All right. So beyond sending this information to the users, what we did, we recently had a user engagement to get information from the stakeholders and fishers on how we could operationalize the WhatsApp dissemination of the safety at sea service. So we met in Togo, where each country was represented by focal points and fishermen. Once we were there, during a meeting, they provided information on how we could present this information that would be useful to them. And also regarding their audio, sending out their audio message in their local dialect, they also provided a lot of feedback on how to send it out to them. So that's beyond just sending information. We also do a lot of user engagement to be able to enhance this particular service. And also, my second use case will be on oil spill dissipation. We know how devastating the effect that oil spill has in our environment. So, for this particular service, we make use of Sentinel-1 data set to detect oil spill. But beyond detecting the oil spill, users or agencies would want to know areas that are likely to be affected by the oil spill. So that is where SENS data set comes in play, especially the data set on waves and currents. We make use of them to be able to feed the model there, the genome model, to be able to predict where oil spills are likely to move towards the areas that are likely to be affected by them. So I have a video that I'm going to play. I'm just hoping this is going to play from your end. I don't know if you could see any movements from my end of my screen. So
yes, we can.
yes.
It's working.
So with this particular service, we make use of the waves and current data set from SEMS, where we feed the model to be able to predict where the oil spills that are detected, where are they likely to go to, which areas are likely to be affected by them. And this are sent as an alert to environmental agencies across the region. Once they have this information, they are able to quickly take a decision or even integrate it with other data sets like marine sensitive areas. And based on that, they can take decisions to address this particular issue. So this is how we use sense data when it comes to oil spill dissipation modeling. Yeah. So also with this, beyond doing this, we also recently engaged nations under the Abidjan Convention. That's countries where we met together in Accra, Ghana, to be able where we train them on how to make use of this particular data sets and how they could also do this on their own. So our focus is to take the workload off us, but enhance the capacity of institutions to be able to do this prediction. So they were trained on how to access data set, the same data set, and how they could feed it into the model to be able to predict or run the oil spill dissipation model as well. So my final use case will be the mapping of potential friction zones. For this particular service, we make use of the physical product and also chlorophyll data set coming from SEMS. What we do is that we access this data set and push it to the generative additive model, where we are able to generate a probability map that will show areas that are likely to find fishing based on the conditions at sea. This particular service enables fisheries agencies to be able to know where fishes are likely to be. And if fishes are likely to be there, then that is where you are likely to find vessels operating, and that is where it's going to be the hotspot for illegal activities as well. So this particular service, we are able to generate this maps and sell it to fisheries managers and coast guards. Once they have this, we are able to overlay with AI's data set, where we are able to track fishing vessels and also know which illegal activities happen at sea. So I have a video here that I'm going to play of a STEM data set integrated with AI's data set, and we're able to find vessels that undertook or engage in an illegal activity at sea, that's transshipment, based on the conditions at sea. We're able to know the location and track all these activities at sea. I don't know if you could see my video player on the map. Some
Yeah, it's playing.
So this is an animation that we are able to detect and really 2 vessels that engage in illegal activities. So this was integrated with the PFZ maps, and we're able to do this and track such activities at sea. It's part of a long animation. I'm just going to fast track it a little bit. So yeah, I'm just going to skip it to the next paragraph. So this is our presentation. This is to showcase how we also, as a but successful as you deliver the services that we provide. Thank you.
Thank you very much for sharing these 3 use cases with us. There are some questions coming, but we'll wait for just a few more minutes before we go to the Q&A session. And we will now have the last presentation of the morning from Jean-Noël Druon from the Joint Research Center at the European Commission. And this presentation is going to be about tracking chlorophyll-a fronts as fish foraging hotspots. So I see that Jean-Noël, you're more than ready and already sharing your screen. So we can see your presentation now, but not in full screen yet, but I'll leave you the floor.
Thank you. So now I should split the screen.
I think it just stopped sharing your screen.
Yeah. So just sorry for this. I just get back to.
Yes, I think we see your full screen.
But you see all the windows.
Yeah, we see the WebEx windows in
So
front.
what happened? Yeah, I know what happened. So let's go back to sharing. Sorry about this. Share. And
If you just maybe, yeah, perfect. All good. We see your presentation in full screen.
but you see that video, right? So should be, it's for moving. Yeah.
Yes.
Okay, sorry for this.
Moving.
So my name is Jean-Noël Druon. I work for the Joint Research Center of the European Commission, which is the scientific arm of the European Commission. And I'd like to present you today a very simple product and indicator for whoever is interested in fisheries and is currently using chlorophyll-a. This should be of most interest. Also to see the trends over the last 2 decades in relation to climate change and fish production in around Africa. So chlorophyll-a gradients and productivity fronts in general are very important for the zooplankton and then for the fish production because they stand long enough to sustain zooplankton production. You can hear the time and spatial scales involved between phytoplankton, zooplankton, and fish, and oceanic fronts are key features for ensuring the transfer of energy from phytoplankton down to the fish. I'm recalling that 80 to 90% of phytoplankton primary production is remineralized, is lost for the upper trophic level, like zooplankton and fish. So we're focusing here on the 10 to 20% of primary production with the productivity fronts that are actively transferring the energy from phytoplankton to fish. Of course, daily ocean color here are a central tool from satellite remote sensing to track those fronts every day. And this is here an example using all sea data, Sentinel-3A and 3B, which are available at Copernicus Marine Services for a year now, using there's the Sentinel sensor, which was launched in 2016. So we're focusing here on the zooplankton, which is the bottleneck again of the entrance of organic matter in the pelagic food web. So the indicator is called OPFISH, the ocean productivity available to fish. It's really linked the chlorophyll-a gradient, which is the green histogram on that plot, with the mesozooplankton biomass. We've been taking continuous plankton recorder data to estimate the mean mesozooplankton, so medium-sized zooplankton biomass. It is a pink curve, and you get the tight link between the increasing gradient intensity of chlorophyll-a and this biomass. Except at some high level here, where we estimate that probably we can see an effect of predation by larger zooplankton and small pelagic fish on this biomass when they are relatively high, up to some level, which even the small pelagic species of fish cannot control the mesozooplankton biomass. So the OPFISH in orange here, that line segment is translating a chlorophyll-a gradient into a 0 to 1 value for a given pixel at 4 kilometer resolution and a given day. So this is the overall results at global scale of this potential fish production indicator, OPFISH. So on the left-hand side, you have the mean value over the last 2 decades. And on the right-hand side, you have the temporal trend, the mean absolute trend in OPFISH unit per year, where negative anomaly are shown in violet, for instance, and here in the West Indian Ocean, and positive anomalies where likely the climate change has been increasing the mixing events by winds, for instance, in the upwelling of Mauritania. So positive anomaly in green, more potential fish production, negative anomaly in purple, showing a potential reduction of potential fish production. So what is important here is that at global scale, you can see natural oscillations of this productivity at global scale. That might come from the solar radiation, El Niño, La Niña, things like that. Except in 2024, here, these low points, that is showing a strong negative anomaly at global scale. And it has been confirmed also using another sensor than MODIS Aqua for 20 years, but using the European Sentinel-3A sensor since 2016. So it's not as low as MODIS estimates, but it is an absolute low value. When zooming around your area of interest, we can clearly see that some regions are winners of climate change, some others are losers in terms of fish production, where the West Indian Ocean is marked by a negative anomaly of potential fish production, while the Mauritanian upwelling area is more like showing a positive anomaly. And in the Benguela current, the upwelling is mixed, let's say, between negative and positive anomalies. But these are strong regional anomalies to take into account in the prediction of potential fishing zones. An example in Tanzania, where you can see that during the northeast monsoon from November to March, the offshore productivity is relatively low. So most of the fish and fisheries, these are catch per unit of effort for small pelagics, and these are for yellowfin tuna. They are mostly like in the coastal area, while in southeast monsoon from May to September, you have a higher productivity offshore, so that the population of small fish is notably is spreading over the entire area. So OPFISH is not yet available at CMES, contrary to the chlorophyll-a gradient, but it is available online within the eStation, which is an online service from the JSE, and you can see the link here. It provides hindcast and in real time, and you can also choose the temporal integration of the last 7 days or the last 15 days or the last 30 days. My advice would be to work probably with 15 days composite, as the productivity features do not change much, usually if they don't move too much in time. So in order to ensure coverage, because in some areas, like in the Guinea current, you may have a cloud coverage which is quite substantial. This is how it looks like on the web, where you need to select so you get a bunch of products also on land, but you need to select oceanography and then chlorophyll-a gradient and OPFISH. So you have also these the chlorophyll-a that is available both for MODIS and Sentinel 3A and 3B, and then select the global 4-kilometer either sensor, and then your time composite and a more or less complex also color bar of your choice in order to get the final results. And here you have the time composite and all the information on the products on the top of the window here for the November 21st, 2025 for the OPFISH estimate that 7 days integration using Sentinel 3A and 3B. I just would like to emphasize one important aspect, that you may focus on the potential fishing zones or this chlorophyll-a gradient of productivity fronts. That's one thing. But if you want to focus on a specific species, you may also want to look at sea surface temperature and these marine heat waves that are more and more impacting especially the tropical areas. And here's an example of the habitat of skipjack in the West Indian Ocean. So it's taking into account the chlorophyll-a gradient as a proxy for feeding, like OPFISH, but it's also including a certain number of physical variables from CMEMS. And what you can see here is the distribution of the temperature and the ISO temperature at 30 degrees that was has been impacting in spring 2024 very largely the skipjack habitat. So the compared to 2022, or just like more than 10 years ago in 2012 for the same month. Knowing that skipjack is escaping the area above 30 degrees, it has been the first time that the person who couldn't find the fish, and the fish processing industry has been working a tide flow for the first time. So don't look only on let's say the productivity aspects, but if you look at some specific species, you want also to look at their maximum, let's say, tolerance to high temperature. So as a recommendation summary, the ocean productivity available to fish is an indicator of potential fish production. It's daily produced, including in real time at 4-kilometer resolution. It is slightly different from the chlorophyll-a gradient because it's also including in relative scale the day duration, how many hours per day a given front is active, which can be quite different depending on the day of the year and the latitude. So Overfish is available from Modis Aqua since 2003 and Sentinel 3A3B since 2016, including real time from the eStation on the Jersey website. But the basic product of chlorophyll-a gradient is available in 2 different products on CMEMS using in hindcast or in real time. Overfish it can be used as a decision tool to better target fisheries control, vessel fishing in hotspot of productivity, and this is to protect small-scale fisheries. When you have large areas to control, you probably want to target first the mean at sea in the most productive areas where the largest fishing is likely to occur. It is obviously providing local variability of fish production under the current impact of climate change, and the trend maps also produce information in order to anticipate food security issue, negative trends, positive trends. This has to be taken into account in the provision of seafood. Finally, I can only say that this tool may be used to increase the fishing efficiency. So you need to make sure that this activity is sustainable and you don't go towards overfishing. And the recommendation for this is just to collect as much as possible fisheries data in order to make sure that those stocks are not overfished. Thank you.
Thank you very much for your presentation. And so we can now go to the Q&A session for our 3 speakers. So I'll start sharing my screen. I see that some of these questions have been answered in the chat by Mary Smith. So thank you very much for writing the answer, but I was thinking some people might not see the written one, so it might be good to answer these questions orally as well. So the first one is, I don't quite understand why these data are not available across all of Africa. So if either Lufono or Marie, you want to give an answer to this one?
Hi, can you hear me?
Yes, we can hear you.
Sorry, I was checking if Lufono was going to answer. Yeah, so I can get this one. So in terms of the GMES in Africa program, so we had our 2 marine consortia. We had our presentation from MarCOSIO, which is covering the southern and eastern sides of Africa, and then MarCNoWA, who is covering the north and west of Africa. So the products and services that MarCOSIO delivered were simply providing coverage for the regions covered by our consortium, just because we had the organizations and everybody kind of promoting the services in the area and the stakeholders in the area. So that's the main reason why they were primarily in just just the southern and eastern parts of Africa. Just data-wise, it gets quite large to handle if we're covering the whole of Africa. Yeah, apologies for that.
Okay, thank you very much for this answer. I mean, we can continue with, we have two more questions regarding the presentation from Lufuno, so we can maybe answer these right now. So the next one is, doesn't the wide difference in spatial resolution between the NRT data and the CMES gaps-free data affect the quality of the products derived?
Yeah, so this is true. So near real-time data, or at least the high spatial resolution, in our terms, the high spatial resolution data are regionally validated, so the products are more likely to provide information that's closer to the truth, just simply because it's able to get finer spatial variability changes. But so we were just providing the gap-free products in order to help kind of fill in the gaps for where the areas that may have had more cloud cover. So, you know, it's not specifically like that we wanted to provide highly quantitative data. It's really just to show whether there has been changes up or down, like broader synoptic changes in any of the products when there was cloud cover. So ideally, you'd want to look at the high spatial resolution products for the best information.
Thank you very much for your answer. And the last one regarding Lufuno's presentation is, how can we ascertain the accuracy of your data for coral bleaching and hotspots?
Thanks for the question. So so the products that we provide there are primarily to help to define areas that are at risk or under thermal stress. And then this can be used to kind of help with monitoring efforts. So basically areas that are under stress people can go specifically out and do in situ monitoring over those areas, or areas that aren't at risk can be potentially used for rehabilitation, or, you know, growing new coral gardens or things like that. But then being able to specifically validate, you're able to check the Cordio Western Indian Ocean Coral Bleaching Observations dashboard. And I did put the link in the chat there. So they actually have the different dates when people were monitoring in situ and the different levels of bleaching that were observed on those dates. So those can be related to the satellite products. I hope that answered all the questions.
Yes, thank you very much. So the next one we received is the USSD code still active, and is it different from the one from the MESA project? Someone tried the code for Nigeria and it didn't work. Is the information for PFZs available or just for selected parties? So I'm guessing this might be a question for Daniel.
Yes, thank you for the question. So the first answer to the answer to the USSD is that yes, we are having challenges with the USSD because of how difficult it is to maintain across the different countries. So that is why we are moving to WhatsApp, because WhatsApp allows us to easily replicate this particular disseminating channel across the different countries. So for the USSD, we are currently moving away from it to the WhatsApp platform. Regarding the PFZ, it's not for everybody, it's just for selected parties. So mostly the fisheries institutions, those are the ones that we actually target for sending this information to. Yeah.
Thank you very much for your answer. And the next question, we just received another one, but the next question is, have you validated the OP fish products with the fish catches in Africa? If Jean-Noël, you want to answer this one?
So the answer is yes and no, in the sense that I put it in the chat, and also in the presentation. There's a number of publication, and the main one is on the chat. on the validation exercise that we've been doing in the Northeast Atlantic and in the Mediterranean Sea, taking commercial fisheries data and scientific surveys, and we estimated a harvest index, which is a simple ratio between the potential fish production, the effective fishing yields, catch per unit of effort or landings per unit of effort for different fishing gears across Europe, including in the Mediterranean Sea, and this potential fish production, OP fish. And we've been highlighting areas that are clearly overfished, especially in the Mediterranean Sea compared to the Northeast Atlantic. So it has been validated on a large range of oceanic conditions, and in the Mediterranean Sea, as far as we can talk about African waters.
Thank you very much for the answer. And I guess this one could also be directed to you. Fish stock assessment is a big problem in informing licensing in Africa. How can or which products are available to assist in fish stock assessment and inform fishing licensing in these countries? I don't know if Jean-Noël, you have an answer to this one.
From my experience, it seems that you really need to work at the species level, of course, and habitat. We've been working on skipjack habitat, and I've been showing, for instance, where we can see a close link between the size of habitat for a given year and the fishing yield. And wherever there was a difference between the habitat size and the fishing yield, it was explained by the fishing mortality, so the intensity of fishing. So if you derive habitats, feeding habitats at large scale for species, especially that are linking to, let's say, feeding in the sea surface, this can be very informative. Or you can also integrate this OP fish as a proxy for feeding for a given species. Of course, if the other variables like temperature are yet favorable. So I think that's a way to inform fisheries management on what are the environmental conditions that are conditioning a given fish stocks. It could be feeding, but also reproduction.
Thank you very much for the answer. And we'll take one last question, as we went over time by a few minutes already. This one is regarding the oil spillage. Is there consideration for the volume of oil spill, and how will it handle extreme events such as storms? And I think this one's for Daniel, yes.
Yes. So for the considering the volume, yes, we do that. We do consider it. From the SAR detections, we are able to detect the size of the spill. So when we are generating the what's it called, the trajectory or the modeling aspect, we actually input the size of the spill into the model, and we also make use of the forecast wave and currents. For the storms, we don't include that in the modeling. So, but for the volume of the oil spill, we do consider, but for the storm, we don't do that. We basically use the forecast data of the waves and the currents to do the prediction of the dissipation. Yeah.
Okay, thank you very much for your answer. So I think this marks the end of the morning session. The webinar is not coming to an end yet. We'll meet again at 2 p.m. Central European time, so in a bit less than 2 hours with more presentations showing you how to access the data, download it, a presentation of the Opera project as well. So yeah, we'll give you a bit of time to think about everything you've learned this morning, and we'll meet you again at 2 p.m. CET. So thank you very much.
The mass concentration of chlorophyll-a in the seawater. So on this map, you can move around with your mouse. You can scroll, zoom in and zoom out if you scroll with your mouse. You can change the projection to the North Pole or the South Pole with these two buttons. With the bar at the bottom, you can change the date of the data displayed on the map. So right now, we are seeing the data for the 28th of November, 2025. But if I click here, you can see that the map was updated. And now we are seeing the data for the 9th of June, 2025. You can also use the arrows on your keyboard to change the date. With the bar on the right, it's the same thing, but for the depths. So right now we are seeing the data at the sea surface level. But if I click here, I'm changing the depth level, and you can see that the map was updated. And you can also use your arrows to change the depth level. All right, so the first thing that we are going to do together is to choose a new layer to add on the map. So to do that, we have to click on Add Layer, and this opens the Copernicus Marine Data Store that was presented to you this morning by Aurore. So I'm not going to spend too much time on this. I'm going to use the filters on the left to choose a product. So I want to focus on the salinity variable. For the area of interest, I am going to select the global ocean. For the temporal resolution, I want daily data that come from a numerical model. And now you can see that we are down to 4 products. I think that Aurore showed you this morning, but if you click on the product, you can read the description, you have some use cases, and at the bottom you have the metadata. Here you have all the notifications to stay updated on the products. In data access, you have the list of all the data sets present in the products. You also have their temporal extent here. And you have the 3 services you can use to download the data from these data sets. And under you have the products documentation with scientific and technical documents if you really want to learn more about the products. So this is the product that we are going to use today. So I have to click on Add to Map. And first, you can see that we have all the layers that are relevant to the salinity, the filter we have selected. And at the bottom, you have all the other layers. So I said that I wanted daily salinity data. So this is the layer that I'm going to add to the map with this button. And now you can see that the new layer was added. I want to talk to you about a new feature that users have been asking for a long time, and it is finally available. So now you have the possibility to add your own data to use them with the MyOceanPro viewer features. So to do that, you have to click on this button, Upload Data. You select a file. You can give a name to your data, and then you click on Upload. So I've already uploaded data, and I'm going to show you how to retrieve them. So you click on Add Layer again. Then you go to Personal Catalog. And you can see that I have uploaded wave data 2 days ago. So if I click here, I can read the metadata that are available for my file. But if I click on Add to Map, I can add a layer. So for example, the sea surface wave maximum 8. Up, fix. And you will see in just a few seconds. Yes, this is the data that I have uploaded. And now I can use all the the viewer features to explore my data. So if you test this functionality, do not hesitate to give us your feedback, or if you have suggestion to improve this new feature, do not hesitate. So for now, I'm going to focus on the functionalities on the left. So you can see that we have 5 layers now. So you have the possibility to hide a layer or to show it with the eye icon. You can also change the layer's priority. You just have to hold one and you have to put it above another one, just like that. And to close a layer, you just have to click here on the cross. Okay, I'm going to keep these 2 layers. So for each layer, you have several features. So first, with this icon here, you can retrieve the product's information. With this icon here, you can quickly switch to another layer from the same products you've selected. With this gear icon, you can customize your layer. So for example, I can change its opacity, I can change its style. So right now for the salinity, we have the solid style activated, but there is also the hatching style like this. And for some layers, there are more style available. So this is the case with the seawater velocity. Right now on the screen, you can see the direction of the current on movement. It's the particle style, and you can change the color. But if you don't want movement on your map, there is the vector style. So I don't know if you can see well, but now we have arrows that are indicating the direction of the current, but without movement. Okay. You have the possibility to change the color of your map like this. You can invert the color map with this button. With this icon, you can play with the contrast of your map. So depending on the threshold you select, you can increase or decrease the contrast. And with this button, you can mask the outliers. So on the map right now, we have values between 30 and 36. But if I say that I want the maximum value to be 35, and then I mask the outliers, then all the values that are outside of this range, they are removed from the map. There is the auto button. I'm going to show you what it does. So let me remove the seawater velocity. And if I zoom on the map right now, you can see that there is almost no contrast. So if I click on auto, the viewer will analyze all the data that is actually visible on the screen, and it will adjust the minimum and the maximum value to create a contrast visually. So yeah, it can be useful. Okay, and then you have the possibility to enable or to disable the log scale for the layers. That's it for the functionalities on the left. Now we are going to focus on the functionalities on the right. So with the MyOceanPro viewer, you have the possibility to create geometries. So you can create points like this. You can create lines. And you can create areas very quickly. And you can see that for each geometry, graphics were automatically created. So you have the possibility to add more graph with this button right here. In a few seconds, yes, the graph is created. You can adjust the axis of the graphics. So you can change the depth level, but you can also adjust the start date and the end date for your graph. Once you're done customizing your graph, you can export its data to 3 formats: NetCDF, CSV, and SVG. And you have the possibility to remove a graph with this button right here, remove graph. You can also group two geometries together. So for example, you just have to grab a graph and you have to put it above another one. And now you have the possibility to compare A, the point, and B, the line, directly on the graphics. If you want to see them better, there is the possibility to click on maximize to make them bigger. And you can always ungroup them with the ungroup button. To remove a geometry from the map, you have to click on the cross icon here, like this. So if you don't want to draw your geometries directly on the map, you have the possibility to import geometries with the import button here. So the geometries can be imported in the well-known text formats, in the GeoJSON format, and in the shapefile formats. We also have preset geometries. So if you don't have, so you can select geometries, for example, for the Alboran Sea, you can just import a preset geometry just like that. And then in the recents, you can retrieve your recently imported or drawn geometries. So here you can see the three geometries that I've drawn just before. All right, and then under you have the settings. So in the settings, this is where you can log in or log out. You can also change the language. And most importantly, this is where you can customize your tool even more. So you can change the way you're displaying the Earth area. You can decide to show the toponyms or not if you want to read the name of the marine areas. You can change the projection here. You can show more statistics on the graphics. You can change the variable units. So there are many options that I will let you explore on your own because I don't have time today to explain everything. Okay, once you're done working, you might want to download data with the MyOceanPro viewer, and this is possible with this button right here. With it, you can subset and download data. So first you have to fill in the different parameters. So the geographic area, you can write the geographical coordinates manually, but you can also click on define on map. If you do, you can select a geometry that was created or imported on the map, or you can, like this, or you can draw a shape directly. Oops, sorry. You can draw a shape directly on the map like this. And I just want to say that if you have a complex shape, such as a triangle, it's not the data inside of the triangle that will be downloaded, but rather the data inside of this shape. Okay, then you have to write the start date and the end date. So you can do that manually, or you can use the as in map buttons. I'm just going to show you how it works. So if I change the date here, and if I click on as in map, you can see that the end date was changed automatically. Same thing for the depths. I'm going to add a few layers. I click on as in map, and now we are downloading several layers of depths. Once you're done setting the different parameters, you have an estimation of the size of the file you're about to download, and you can just click on download. Sometimes it can happen that the data you want to download is too large. Let me show you. Okay, so if the data you want to download is too large, you will get this red warning. So the first thing you can do is try to reduce the size of the data by changing the parameters. But if you don't want to do that, there are other ways to proceed. So you can use the file browser by clicking on the Browse Files button. So if you use the file browser, it means that you're going to download the original data as uploaded by the producers. So here we are using a daily data set. So it means that the data are what I'm going to show you. So if we click on the year, then on the months, we have one file per day. Because this is original data, one file will contain all the depth levels, the whole geographic area, so the global ocean, and all the variables. So this is why the size of the file is quite big. But this is what you do when you use the file browser. Another way that might be more effective is to use the automate button. So all the parameters you have selected before, they are written in the Copernicus Marine Toolbox format for the command line interface or for the Python API. You just have to copy the request and then you can use it to download the data with the Copernicus Marine Toolbox. If you don't know about this tool, I'm just going to present it when I'm done with the presentation of MyOceanPro. But yeah, this is a very useful tool, you will see. You might also want to share your work on MyOceanPro viewer. So to do that, you have to click here and you have the possibility to create a URL link that will contain all the layers you've added, all the geometries, all the graphics, all your work, basically. You just have to copy it to send it to someone. You can generate an image. You can generate a video in the MP4 or GIF format. So you can choose the start date, the end date, the duration of the video, and so on. And then you can create a named link so that you can include the MyOceanPro viewer tool into a website, for example. With this icon here, you can check the viewer's shortcuts. So if you use this tool regularly, I recommend you to check them because they can be pretty useful. And finally, with this icon here, you open this widget. And so first, if you're looking for answers, I recommend you to click on help. So this space is connected to the help center. You can just type in, for example, MyOceanPro. First, you get this article, Introduction to MyOceanPro Viewer. And this article, basically, it contains all the information I gave you during this presentation. So you might find your answers in there. But if you look at our articles and you don't find your answers, you can always click on messages and then ask a question. First, you will be talking with Blue, our AI chatbot. But if its answers are not satisfying, you can always ask to talk to a human member of the user support team, and the conversation will be sent to us, so we will help you. Okay, I think that I'm done with the presentation of the MyOceanPro viewer now. If you have a question, don't hesitate. If something was not clear, I will try to answer your question. Now I'm going to talk about the tool, the Copernicus Marine Toolbox. Sorry, the tool I was talking about earlier when I was here. So I'm just going to open my PowerPoint. Okay, so as I was saying before, the Copernicus Marine Toolbox is a useful tool. It is free and user-friendly, and it is designed to interact with the data store. This tool allows many possibilities with its 4 main functions that you can see on the screen: login, describe, get, and subset. With login, you can automatically generate an encrypted file that will contain your username and your password, and it will be stored on your machine so that you don't have to write your credential each time you want to download data. With the describe function, you can retrieve the products and the datasets metadata. With the get function, You can retrieve the original files as delivered by the producers. And with the subset function, you can download only the part of a dataset that interests you. So we will see all that later. But the advantage of the toolbox is that there is no limits on the volume size of the data you want to download or on the bandwidth. So one of the advantages of the toolbox is its ability to download data with significantly improved performance, and this is due to the conversion of all the datasets to the ARCO format, which is the analysis ready cloud optimized. So analysis ready means that the data have been homogenized for ease of use and interoperability for both time series and geospatial queries. And cloud optimized means that the state-of-the-art technologies were used to store data optimally and to enable fast parallel access to the data. The Copernicus Marine Toolbox offers these new access services via 3 services: GeoSeries, Time Series, and Original Files. To explain, the GeoSeries service provides a version of the data with a large chunk size for the latitude and the longitude dimensions, and a small chunk size for the time dimensions. So it is optimized to analyze a large geographic area over a short period of time. The Time Series service provides a version of the data with a small chunk size for the latitude and longitude dimension and a large chunk size for the time dimensions. So it is optimized to analyze a complete time series over a small area. And with the original file service, it provides the original version of the data as published by the producers. The thing with the toolbox is that it automatically switches between these 3 services depending on the user's request. During this presentation, I'll show you the main features of the Copernicus Marine Toolbox and some examples so that you will see how easy it is to use. The toolbox can be used both on a command line interface, such as Mamba's MiniForge prompt, but also on a Python interface, like Jupyter's Notebook, or a code editor like Visual Studio Code. During this presentation, I will use the toolbox only on the command line interface because I won't have time to use it on the Python interface. So we are going to start at the beginning, and we're going to go to the Help Center. So in the Help Center, this is where we have all the articles about our different services, our different tools. So it is a useful place for you. If you want to look for the information about the toolbox, you have to click on the Copernicus Marine Data Download section. Then you have to scroll down and you have Copernicus Marine Toolbox. So in this 4th section, you have all you need to work with the toolbox. In the Getting Started with the Toolbox section, basically you will find the information I just gave you at the beginning of the toolbox presentation, but there are 3 important articles. Installation, that explain how to install the toolbox properly on your machine. Executable, that explain how to use the toolbox without installing it on your machine thanks to an executable file. And credentials configuration, an article that explain how to use the login function, but we will see that later. In the main functionalities, you have articles about the main functionalities of the toolbox for both the command line interface and with Python. In use cases, we have articles that explain how to use the toolbox in specific cases, but also with different softwares and languages. And in troubleshooting and FAQs, you will find your answers if you're encountering an issue with the toolbox, or if you have a question. You can also learn how to report an issue or how to request a new feature for the toolbox. Okay, for the sake of this presentation, we are going to pretend that we have all installed the toolbox. So it means that we have created an environment dedicated to the Copernicus Marine Toolbox. So from there, the first step is to open the Mamba's MiniForge prompt. It is here. And we have to activate this environment in which the toolbox is installed. So to activate it, we have to do Mamba activate. So Copernicus Marine 225 is the name of the environment I have created and in which the toolbox is installed. To check if the toolbox is properly installed, we can call the toolbox package, which is Copernicus Marine, and then we can ask with version. We're going to ask which version is installed, and it's the version 225 that is installed, and it is the latest version available. So the first function that we are going to see very quickly together is the describe function. Just to remind you, with describe, you can retrieve the products and the dataset's metadata. So I want to show you how to look at the functions options. So first you have to call the package, then you write the name of the function, and then you add help. By doing so, you will have a list of all the options on the left here, and on the right you have their description. So at the bottom you have two examples of lines that use the describe function. But today I won't have time to show you more about this function because it is not the most interesting function to show, but it is pretty useful. So I recommend you to check the article in the Help Center. What we are going to do together is we are going to see how to use the login function. So, oh yes, before I do it, I just want to remind you that the login function is used to create a credential file that will be stored on your machine automatically. And that way you won't have to write your username and your password each time you want to download data. So this login function is here to speed the download process for everyone. So to use it, you just have to call the package Copernicus Marine, and then you write the name of the function, login. Then you will be asked to write your username and your password, and you have to be careful because the writing of the password is hidden. Then you press enter, and your credential file will be created. In my case, I already have this credential file, so it is asking me if I want to override it, and no, I don't want. But yes, it is that easy to use the login function, and then you won't have to write your credentials when you download data. And this is a function that you only have to use once, or then you can forget about it because your credential file will be created. Then we are going to see the get function. So with get, you can download original data as delivered by the producers. First, we are going to check the options available with get. So we call the package, we write the name of the function, and we add help. This is the same process. And now you can see that there are many options with get, but only one is mandatory, and it's dataset ID, because we need to at least specify from which dataset we are going to download the data from. So we are going to write a get request together. So first we have to call the package, then we write the name of the function get, then we write the name of the mandatory option, dataset ID, and we have to write a dataset ID. So I'm going to go back to MyOceanPro, and I'm going to use the same dataset we've used before. If you remember, I told you that if you click here, you can retrieve the product's presentation, the description, and in data access, you have the list of all the datasets. During the MyOceanPro presentation, we have used this dataset, Salinity Daily. So I click here to copy the dataset. I can go back here and I can pass the dataset ID. I could run this request as it is right now, but if I do, I would be downloading a lot of files. Yes, it would take very long. So what I'm going to do is that I'm going to use the filter option so that I can filter which file I want to download, and I'm going to download a file for the 1st of January 2025. I'm also going to add the option output directory so that I can specify where I want to save the data. Actually, I want to save my data in my data directory, and that's it. We can run the request. So the toolbox is giving us some information about which dataset version was used here, and which dataset part here. Okay, and it should take, okay, it's done. So number of file to download 1, the request was successful. If I go check my data directory, there is this directory that was created with the dataset we have selected, the year, the months, and the day. So we have our file for the 1st of January 2025. So there are many other options with Get, as you can see, but I won't have time to show you all of them. So you can either use this command to read the description of each option, or you can go to the Help Center where everything is explained. And now we are going to use the subset function. With subsets, you download the part of a dataset that interests you. So you choose the variable you want to download, you choose the geographic area, you choose the depth layers, and the temporal extent. We are going to check again the options available with subsets. And you can see again that there are a lot of options with subsets. At the bottom, you have two subset requests that are shown as an example. And I can understand that as a beginner, writing such a request can be complex, but I'm going to show you an easy way to create a subset request. And actually, I've already shown you. If you go back to the MyOceanPro viewer, I told you that with Automate, we could create a request directly for the toolbox. So I'm just going to change the parameters here. Okay, I'm going to change the names. Okay, so once you have set your parameters, again, you can click on Automate. Then you just have to copy this. You go back to the prompt and you paste it. So I'm going to add more options here. I'm going to specify where I want to save the data with output directory, as I did with Get. I want to save it in my data directory. And I'm also going to use the option output file name. With this option, you can give a name to your file. So I'm going to call it salinity data. And I run the request. Just to show you how the requests work, first we have called, First we have called the package, the toolbox package, then we write the name of the function, the dataset ID option with the dataset ID, variable with SO, the salinity variable. We specify the temporal extent, so the start date and the end date. We write the geographical coordinates, the minimum and maximum longitude and the minimum and maximum latitude. And then we write the depth levels. So here you can see that the minimum depths and maximum depths have the same value. It's because we are just downloading the surface level. So the data was downloaded very quickly. And if we go check the data directory, I have to go back. Okay, I'm in data, and you can see the salinity data file was created. Again, there are a lot of options, and I recommend you to check them because they are very useful. Okay, so I have presented the main function of the toolbox, but there are some other functions that are pretty useful, like the open dataset function, with which you can open the data remotely without having to download them. So I highly suggest you to check our articles, at least in the main functionality section. I'm done with this presentation now. If you have a question about the toolbox or about the MyOceanPro viewer, don't hesitate, and I will try to answer them. Thank you.
Thank you very much, Leila, for this these great demonstrations. We just have a few questions, so I will start sharing my screen. The first one is about the fact that this demonstration is quite hard to
Yes.
follow, and I know it could be even more complete and you could show a lot more things, but what I did is I shared in the chat the link to the article you showed us earlier. And also just a note to say that we'll be sharing a link to the replay of this session, so you can rewatch the demonstrations as many times as you want. And I'll share this a bit later as well, but we have the Copernicus Marine Service has a YouTube channel with replays from past events, and this demonstration of the toolbox and viewer have been done many times before, and so you can rewatch basically any of the trainings that we've done, and you'll see the demonstration as well. But I don't know if Leila, you'd like to add anything on this first question.
Just that I'm sorry for going fast. I'm just trying to show you as much as possible. So I understand that it can be hard to follow. But yes, we have the video in the article and the replay, so it's all right.
Yeah, I think this was a really great introduction to these two tools, and there's definitely a lot more you can explore at a later date, and so you can do so on your own by going to the viewer and playing with it, but you can also definitely rewatch watch some replays. And then, so I guess the second question that we have is what happens if you overwrite the login file?
It just recreate the file. It's not a problem, but I just didn't want to do that. But yeah, nothing bad happens.
That's good news. Okay, thank you. And we just received a third question, which is, can you download the data, as TIFF instead of NetCDF, I guess?
Yep. So with the MyOceanPro, no, it's not possible. And with the Toolbox, no, it's not possible either. But you could use the wait, I'm thinking. I think that you could use the Toolbox on a Python interface and manipulate the data, maybe to convert them, but you can't download them to the TIFF format directly.
Okay, thank you very much. I don't see any other question coming in for now. Oh, actually, just two came in as I was saying this. Okay, so let me show them on the screen. So the first, oh, sorry, so one disappeared. So let's have a look at this one while I find the other one. What is the accuracy at a micro scale?
So it depends. I think you're talking about the MyOceanPro viewer, and it just depends on the product you select.
Okay, thank you very much. And I think the question that disappeared just before
Yes,
was
was
this
this
one.
one. Yeah.
Is there a limit of size or requests by user or by day?
No, there is no limits. You can
Okay.
do as many as you want.
Okay, thank you very much. I'll just leave it for a few more seconds, just in case anyone is writing at the moment. I'm just checking the chat. Okay, no question incoming in there as well. So thank you very much, Leila, for these demonstrations. As we said, you'll get a link to the replay of the session and you can watch these again whenever you have time to learn how to use these two tools. So thank you very much.
Thank you.
And we'll move on to the next presentation, which is from Andrea Carvalho. And Andrea is going to do a presentation on the Copernicus Marine Service ocean literacy resources that we mentioned briefly this morning, and other resources as well that we haven't talked about yet. So Andrea, are you with us?
Yes, hello.
Hi.
Hello, everyone. Yes, I can share my screen already, I guess.
Yes, please go ahead.
Perfect. Okay. Let's see if this works.
Your screen sharing just stopped, I think.
Just stopped. Oh.
Yeah.
And what about now? Can you see my presentation? Yes. I guess, right?
Yes, we can see it in
Perfect.
full screen now.
Perfect. Great. So yes, my name is Andrea. Thank you for the introduction, Marine. And I work at MarCOSIO International, and my job is to communicate science and to help translate science to different audiences, mainly to non-scientific audiences. And so today I will give you a little overview of what kind of resources do we have in Copernicus Marine Service, what you can find that can help you understand the state of the ocean, can help you understand the main threats to the ocean at the moment. And so we have different resources applied more or less to different audiences. And so I'll give you a short overview of each of them today. So the Ocean Explainers. These are very informative pages with infographics and illustrations. And the idea is really to give you the basics. From explanations of what is a current, what is a wave, to a little bit more developed explanations of what is ocean acidification, so threats or phenomena like certain currents, why do they happen the way they happen. So these are really interesting. These are really nice pages that you can use, for example, for educational purposes, but also if you're interested in just knowing more about the ocean and the interactions with the atmosphere or ocean and climate and all of that. And also operational oceanography. We have a specific page dedicated to operational oceanography, which is core activity behind the Copernicus Marine Service. So if you would like to know how we take data from buoys and drifters and all that, and we put it into our models, as well as satellite data to run our forecasts. That's a really nice place to start the Ocean Explainers. Okay. Next, we have the Ocean Climate Portal. It's a more or less interactive page based on the ocean monitoring indicators. I think you had a presentation this morning about those, about the ocean monitoring indicators we have. So this Ocean Climate Portal focuses on key indicators such as sea level or sea surface temperature, and it talks about the trend. It shows the trend of this indicator for the last 30 years. So it's a long-term measurement, and it explains what does that mean, why is this important, why should we pay attention to this trend, if it means is something positive or if it is something negative. And so it gives really valuable insights about the state of the ocean, for example. And next we have ocean visualization tools. You you just saw a demonstration given by Leila before from the MyOceanPro. So one of the ocean viewers, which is more for someone who's already more confirmed user, maybe, or someone who's already knows what it's looking for. We have two other viewers, MyOceanLearn and MyOceanLite, who are for more, let's say, either a younger audience or someone who doesn't know so much about the ocean yet, or ocean parameters, like what is sea surface temperature, for example. And so, for example, MyOceanLearn is a very nice tool to start with schools, or, for example, in exhibitions. We've had something very similar to MyOceanLearn exhibited in the UN Ocean Conference last June. We have MyOceanLearn in certain museums as well here in France, and all these three viewers are very easily embedded in any web page. So anyone can embed these viewers in their own website to show, for example, what is the temperature in the Mediterranean Sea somewhere. So yeah, just to let you know how accessible all these tools are and how you can use them freely, all these resources for different intentions. Yeah. And so, yeah, for especially visualization tools, we are constantly upgrading them and creating new tools. We are currently developing two new visualization tools. One will come out in December this year and another one next year, just to give you this update so you can keep keep your eyes up on the next developments on what is coming out. Another key activity of the Copernicus Marine Service, besides providing, of course, free and accessible data to everyone, we also report on the state of the ocean. So it's a very key and long activity we do, and this means every year we publish a report on the state of the ocean, so on key findings about the temperature of the ocean, the heat that has been accumulating, acidification, and phenomena or extremes. But this is a very dense report and is scientific report, still remains scientific, very scientific language. So what we do is we shorten this report and we take the main key findings of this report and we transform it in a version that could be read by anyone. Anyone could read and understand, oh, okay, this doesn't sound so good, or interesting, this happened in 2024. So we create this summary, which is for general public, policymakers, and both these documents are supposed to be reference documents for organizations, governmental bodies, everyone. And something else. At Mercator, we monitor marine heat waves and sea ice, and also sea surface temperature, among other parameters. But these three topics we monitor very closely, and we publish bulletins very frequently. And so in the Copernicus Marine Service, you will find some news. Every month, we do a recap of these bulletins with the key findings for these three topics. And so you can find those in the news section of the Copernicus Marine Service as well. So this is also, so it's literacy and it's also information, mainly in this case, well, for everyone, of course, but a lot of journalists can also be interested in this kind of news. So we try to touch all sorts of audiences with our resources. And so more recently, so every every summer, we are contacted by journalists mainly who are interested in knowing what is the state of what is going on in the Mediterranean, for example. So during the summer season in Europe, the Mediterranean Sea is often touched by extreme heat waves, and to facilitate the journalists and the way they could find information. And we have created 2 tutorials, one explaining how to access a little bit more superficial to what Leila has done before, a little bit shorter than what Leila did before, but basically just to explain how they can create their own illustrations to their stories, and also how they can find other information related to sea surface temperature, sea ice, and other parameters in the Copernicus Marine Service. And I think that's all from my side. It was a very quick overview. I hope it was clear for you guys.
Yeah, thank you very much, Andrea. It was very clear and a very good overview of everything the service has to offer. I don't think we have any question coming in for you, so you must have been super clear.
Super clear. And in any case, if there's any questions later on, we can always answer. Yeah, we still stay here.
Yeah, of
Okay.
course. So anyway, we'll continue with the last presentation of the day, which is from Liliane Diarra, who is the Opera project manager. And Liliane is going to do an introduction of this project. So Liliane, can you hear us? Oh, we can see your screen.
Yes, can you hear me? Can you hear me?
Yes, we can hear you.
Okay, and you can see my screen. Sorry.
Yes, we can see your screen.
Okay, and it's in the slideshow mode, right?
Yeah, in presentation mode. Sorry. Go ahead whenever you're ready.
Yes. Hold on. Okay, so my name is Liliane Diarra. I work at MarCOSIO International, and I'll be speaking about Opera. So Opera is a European-funded project that started this year. And there are a lot of synergies with Copernicus Marine and, of course, with GMES in Africa. And this is why I was invited to come and speak to you about this project. Okay, so OPERA stands for Ocean Prediction Enhancement in regions of Africa. Its overall goal is really to improve the sustainable use of marine resources and human welfare in sub-Saharan Africa by really focusing on strengthening ocean prediction and its application. How are we going to do this? We're going to collaborate with African regional centers of excellence. So these are marine institutions involved in ocean forecasting or ocean data, and we're going to strengthen ocean forecasting systems, capacity and cooperation around ocean forecasting, and really promote its practical application based on African needs and priorities, and of course, linking to the global ocean prediction community. So it's a 5-year project that's been recently extended by 1 year. And also it has a budget of 10 million euros. This also has recently been topped up. So it was initially a budget of 7 million euros. And over the last months, we've been working on having a top up of 3 million. So that gives us a nice round figure and more activities, which will make it more impactful. And I'll try and explain these. So it's a project that's implemented by Mercator Ocean through its coordinating role of the Ocean Prediction Decade Collaborative Center, and of course leveraging Mercator Ocean's expertise in the Copernicus Marine Service and the European Digital Twin Ocean. So where does Opera come from? How did it come about? So Opera is actually part of a bigger European Union program called ARC-X, which is the Africa Regional Centers of Excellence program. This program is run by DG INSPA, which is the European Commission's Director General for International Partnerships. And it really aims to strengthen digital science, technology and innovation capacities in sub-Saharan Africa towards scientific knowledge-based innovation, sustainable development. So this is really focusing on Africa's green transition. The ARC-X program has 5 components. So this year, Opera joined in as the ocean component. and next year a new climate component will be launched. So of course, all these components work separately, but there are a lot of synergies because of, especially with the ocean connects to all the different components, and we try and work together with the other components to see where we can actually join forces. So Opera also is aligned, Opera came about through the ARCS program as the ocean component, but also Opera came about as a need identified by different frameworks, so African and European policy frameworks. So we have the AU's Africa Blue Economy Strategy, the AU Agenda 2063. We've got, of course, have the EU Ocean Pact that was launched this year, the Global Gateway Strategy, the Ocean Decade Africa Roadmap, and others. And of course, everything that was in the proposal of Opera, everything concerning related programs like GMES in Africa, amongst others, were of course all the considerations that were taken into account in developing the proposal. Opera was also informed by a survey that was launched, I think, 2 years ago now, and it was really focusing on the current state challenges and future prospects of ocean forecasting in sub-Saharan Africa. And some of the big things identified as a need were community building and knowledge sharing, capacity development, really developing this new generation of scientists and technicians, the need for new forecasting services, the need for new and improved applications integrating ocean data, really looking especially highlighted with disaster risk reduction, and user uptake and societal engagement was also one of the big topics identified in the survey. The link is here, but of course, I hope these slides will be shared so you can have access to this. It's a nice report, and then we had quite a lot of, we had 139 responses, and this really also helped form the Opera proposal. So Opera objectives, now to get into what is Opera. So there's 6 objectives. The first one is really focusing on building a community around ocean forecasting and strengthening cooperation, and of course, growing Africa's voice in the international community of ocean forecasting, voice and contribution. The second one is really to strengthen capacity building and really ensuring the community has better access and is able to use digital ocean resources. The third one is really looking to strengthen ocean forecasting systems for essential ocean variables, so currents, sea height, temperature, salinity, both on the regional and coastal scale, and obviously this is contributing and complementing what is already proposed by Copernicus Marine. The third one is really based on all the different systems and data available to develop innovative ocean data-driven applications, services, and tools to really focus on African needs and priorities, from disaster risk and reduction to supporting sustainable blue economies and to safeguarding marine ecosystems. The fifth objective is to develop an African digital twin of the ocean, an ocean knowledge hub. This is a priority identified in the Ocean Decade Africa Roadmap. And this is really to enhance the sharing, accessibility, and use of ocean data for informed decision-making, and also have an environment where you can actually run applications and extract the information needed for decision-making. And the last objective is really to strengthen the uptake and long-term impact by really engaging users and stakeholders from the beginning of the project through co-design and targeted activities and knowledge tools, but also really focusing on both the science to policy links and also having some private sector engagement. So this, in a nutshell, is what Opera is trying to do. And now I'm going to go through the different, let's say, activities, the main activities, and also to give you an idea of how you can get involved and how it's also linked to Copernicus Marine. So as I mentioned, the first objective is really to strengthen this cooperation and community around ocean forecasting. So here we already have, there's a large community, it's very scattered, so Opera really is going to try and bring this community together. So this is linking with communities such as GMES in Africa, linking with the Ocean Decade Africa Task Force, IOC Africa, Goose Africa, other blue economy programs in Africa, and really trying to bring them together through this atlas of ocean forecasting that is available on the Ocean Decade, the Ocean Prediction Decade Collaborative Center. So if you go to the Ocean Prediction Decade Collaborative Center, there's already an atlas of different experts working in ocean forecasting, as well as the systems in place. And if any of you are working with ocean forecasting systems and data, we invite you to join this network. And you feature on the map, as you can see on the right. But this activity will also really look to map and promote ocean forecasting activities in Africa. We're going to activate an online forum for knowledge sharing and collaboration. This activity is also, of course, going to be really focused on disseminating all the results in opera, and of course, annual events and workshops, really to promote everything that's happening in opera and beyond. When we look talking about strengthening capacities and knowledge sharing, so we have a very extensive capacity development, let's say, component. The first one is really which is actually divided into two parts. So the first one is really open to all, and it's going to be very much online. And this will entail ocean literacy activities, production, dissemination of ocean literacy activities, and of course we're going to leverage everything that's already been developed within Copernicus Marine that my colleague Andrea has just presented, but also build new materials that really focus on the African landscape. We'll also develop 4 massive online open courses to really understand and use ocean forecasting data. And these massive online open courses are really going to focus on this virtuous loop of ocean forecasting, if you can see on the right. The first one is really focusing on the fundamentals of what is ocean forecasting, how does an ocean forecasting system work. The second MOOC will be really focusing on how to wire the different components of an ocean forecasting system, so how to build an ocean forecasting system. The third MOOC will be looking at how to evaluate and upgrade your ocean forecasting system with this notion of an operational readiness level guide. And the fourth component, the fourth MOOC, will focus on digital twins and, of course, applications and services. So once you have all your ocean forecasting systems in place, how can you use the data and information coming out of these systems to develop services and applications? So for this part, for these capacity development activities, we had an open call, and we have actually already found the consortium that's going to take care of these activities, which will be announced in early December, so that we hope to start these activities as early as January. And then the second component of the capacity development is really going to look at accompanying the different, let's say, African partners participating within opera. So this is really to to select technology transfer teams. So these again will be selected through open and competitive calls, which will be launched in December, and another one in January, to really find teams that have the expertise to accompany the different African consortia to develop the different ocean forecasting systems and applications needed, and to provide some kind of mentorship throughout the project. We'll also hold 2 in-person training courses during the course of the project. There will also be some long-term visits to the technology transfer teams, and as well as to Mercator Ocean, in particular with the European Digital Twin Ocean team, and I'll explain why in a minute. So the heart of the project is really to establish these African regional centers of excellence. So we have, let's say, two different types of regional centers of excellence. The first type is really centers of excellence that are really focusing on applications. So through a call for grants, which will be launched before mid-December, and it will be open for 90 days, we are going to select 2 consortia of African partners, of up to 5 African partners, of one being the leader, to build up to 2 applications each. So there'll be 4 in total. And these applications are going to be decided by the African partners. So in the proposals for the grants, they're going to justify the applications they would like to build. But of course, this could be anything from early warning for storm surges, coastal flooding. It could be predicting oil spill trajectories. It could be marine weather forecasting, etc. But basically, the need has to come from the African partners. They need to organize themselves and apply for the grants. And of course, ideally, it would be nice. It would be really great to build something that's already to to align what is being built here with what has been built already in GMES in Africa, so we're not reinventing the wheel. And of course, all the applications that are going to be built will be hosted on this African Digital Ocean Framework, which will be taken care of by another work package, which I'll speak about in a minute, so that we integrate all the different applications and data in one single portal. And then the second type of regional centers of excellence, there'll be one, sorry, there's a typo here, but this regional center of excellence will be really focusing on the development of ocean forecasting systems. So the title should be Regional Centers of Excellence for Ocean Forecasting Systems. And here is really to have one consortium dedicated to building state-of-the-art regional ocean forecasting, one regional ocean forecasting system, and up to 4 coastal ocean forecasting systems for essential ocean variables. And the idea here is to really make sure that all the results are interoperable. They'll be following the data standard and architecture established by the Ocean Prediction Decade Collaborative Center, and everything will be integrated and made accessible through this African Digital Twin Ocean Framework. And this call to establish this consortia, again, there will be a competitive and open call for grant proposals. So these, I mean, these diagrams are just indicative. This is not how it's going to look, the consortia and where the different partners will be, but just to give you an idea of how it could look like. Then a new component with the top up that I mentioned is really to develop this African Digital Twin Ocean Framework. We're not starting from scratch. The idea here is to really leverage everything that's been developed in EDITO, the European Digital Twin Ocean. Right now, there's a Digital Ocean Forum taking place actually in Brussels, and they're discussing the different developments. But if you are interested, I do invite you to look at what's happening here, because this platform is really trying to bring all the different EU assets together in one single place. So whether it be Copernicus Marine data to EMODNet data, having some kind of simulation environments to run your applications. So this the idea for the African Digital Twin Ocean would be really to leverage all the infrastructure and technological developments from EDITO, which is a European Digital Twin Ocean, and build something for Africa. But this, of course, will be co-designed with all the different African consortia, and really to ensure ownership and management beyond the project end. So there will be a call for this development that will be launched next year. There will also be another call for consultant to conduct a scoping exercise, and this will be launched in December, to really understand what is available in terms of data infrastructures, connectivity, data sharing in Africa, and this will really also inform the development of this African Digital Twin Ocean. So what will it encompass? This African Digital Twin Ocean will be able to host the deployment and access and provide access to all the applications developed within Opera. It will grant access to Opera Copernicus Marine selected global products that are relevant for the African community and other local data sources. There'll be a visual front-end interface, there'll be dashboards and viewers. There'll be access to the forecasting systems developed within Opera, and there'll be other places for demonstrations from the private sector, demonstrations for the policymakers, and so on. So we're really excited about this component because it was really missing from the original proposal, something to bring everything together in a single platform. And this it could be like a mini, you could think about it as a mini Copernicus Marine for Africa. So other activities that have been added thanks to the top off is an activity focusing on, sorry about that, on service maturity and user engagement. So this is once all the applications and systems have been developed, the idea here is to user test them, to conduct evaluations on the operational readiness level, on the technological readiness level, and come up with a roadmap for future evolution. This will also be a way to secure additional funding beyond the project end. There is also a new component really to engage with entrepreneurs, and this is really to support the business, to support the development of business ventures from Opera products, but not only from Opera products. They could also be products and applications that have been developed within GMES in Africa, but it's really to foster dialogue with the private sector for uptake of ocean data. There'll be a competitive call for this to find an incubator or innovation lab to support this activity, and this should be launched next year. And then the last one is really to strengthen the science to policy interface and make sure that all the results are sustainable and taken forward beyond the project end. And here we have set up actually an upper advisory group. The first meeting will be tomorrow, and this advisory group will really try and inform and provide recommendations for these activities. So just in a nutshell, OPERA will have the first consortium, really building these regional and coastal ocean forecasting systems. We have 2 consortia focusing on applications. So again, this is indicative. It might not be where they're positioned, but just to give you an idea that we're looking for something very geographically balanced. OPERA, I don't think I mentioned it, is limited to sub-Saharan Africa. So only sub-Saharan institutions in coastal countries in Africa are eligible to apply for these grants. Then we have business ventures based on the different systems and data and applications that are developed. All this will be integrated within an African Digital Twin Ocean framework that is adapted to different users, from policymakers to business practitioners to the economy actors. And to enable this environment, of course, we're going to support by establishing these technology transfer teams that I mentioned to help co-design the software development, provide mentorship. We'll provide training. So as I mentioned, we have the global strategy of online training with the MOOCs, advanced training materials, and ocean literacy, but we'll also have some in-person activities, as I said, the summer schools. Then we'll have user engagement and stakeholder engagement activities, very important. Community building, so this is the forum, the different connecting between communities. And then we'll also have some acquisition of hardware, including 1 supercomputer for the different consortia. And this will be supported by the OPERA Advisory Board and, of course, support from the European Commission's ARCS, let's say the ARC-X ecosystem. So who are the OPERA beneficiaries? So this is really the institutions and operational services involved in ocean monitoring and forecasting. Of course, the African Union Commission, regional governing bodies, national governments. We have the UN bodies, so as IOC Africa, GRUS Africa, the UNEP African Sea Conventions, local authorities involved in coastal zone management and disaster risk reduction. Of course, the blue economy actors who need ocean data and forecasting services for their different activities. So from fisheries to port services, tourism, offshore energy. We have the private sector that also have a lot to gain from this new provision of data, and the civil society, so from NGOs to community-based organizations. So the upper timeline. So this year was very much preparation, scoping exercises, consultations with different partners, setting up of the governance structure. From next year, we are going to start implementation of the project. So this is really all the different partners will be in place, and the different developments can start. So from the ocean forecasting systems to the applications and tools, we can start working on this African Digital Twin Ocean platform. Capacity development activities will start, and so will the stakeholder engagement activities. And then from 2027 onwards, right up to the end of the project in 2029, really hope to see the operationalization of the different systems and applications, and really with a focus on sustainability and impact scaling. And this is in a nutshell the OPERA timeline. So links between OPERA and the Copernicus Marine Service. So really, OPERA will build on Copernicus Marine resources, and of course involve the GMES and Africa community of users and participants to really develop regional and coastal systems tailored to African regional needs. So there'll be a lot of downscaling from global products with the needed resolution for coastal monitoring. There'll be enhanced local and regional ocean modeling capacity. We hope also with the project to strengthen the ability of national and regional institutions to use Copernicus Marine products, as well as OPERA products operationally. We're going to really foster the development of user-driven services and tools to support decision-making in both the public and private sectors. And we'll, with the African Digital Twin Ocean, really hope to integrate the African Ocean data offer from Opera, from Copernicus Marine, and from local sources in one single platform. So I'll stop here. I don't think I took 30 minutes. But of course, if we have questions, please, we're going to have a panel, I think, right now. But I also invite you to scan the QR code to go to the Opera project page, and also join the UN Ocean Prediction DCC community. Sign up for the newsletter to be kept up to date on all the different Opera opportunities and results. Thank you. I think I'll stop sharing my screen.
Thank you very much, Liliane, for this very comprehensive presentation of the Opera project. Yeah, as you said, we have a Q&A session planned now for both yourself and Andrea. We haven't received any question yet regarding your presentations, so feel free to ask any question that you'd like to ask now. I think either on Slido or on the chat section, or for the last Q&A session of the day, maybe we can allow participants to open their mic if any of you would like to ask a question orally. I'm monitoring every channel. Okay, well, I don't see any incoming questions, so once again, you must have been super clear as well. We've posted in the chat some links to resources that were mentioned by Liliane. So don't hesitate to have a look at these. And we'll definitely share the presentations from speakers today, so you can have the opportunity to have another look at them later on if you'd like. Oh, actually, I can see one question incoming, so I'll just approve it. And I'll just start sharing my screen so you can actually see it. Okay. Oh, and another one coming. So the first one is there any role for members of the European space networks, especially the Copernicus ambassadors in Africa? I don't know if Liliane, you'd have an answer to this.
I'm not sure what that is, but of course, in all activities, whether it be capacity development, whether it be our annual workshops, the committee is invited to be part of this, and of course, all the technology transfer teams that will be set up. These, both European and African experts can apply to be part of these teams. It's not only limited for African institutions. The only thing that's limited to African institutions are the actual consortia, let's say the consortia building, that are actually the core of the project. But there are different calls that are open to other participants, and this could be something interesting for these members of European space networks.
Thank you. And I guess the second one isn't really a question, but an encouraging message saying the project is interesting and we hope we can be a part of it. So I think Liliane explained all the ways you can be part of it. So once again, you can refer back to the presentation.
Yeah, and I just want to say one more thing. So mid-January, we're going to have an information session on Opera because the call for proposals for the grants to establish the different African partner institutions will be launched before mid-December. So we'll have an open session in mid-January. So I invite you all to follow the Ocean Prediction DCC communication channels to be informed of this session.
Okay, thank you. And another question just came in, which I mean, yeah, it's a legitimate one. We hope you extend the project to North Africa. We are also Africans. And do you have any perspective for us?
No, I totally agree. But unfortunately, this is something that was decided by the European Commission because of their focus on sub-Saharan Africa. However, there are a lot of opportunities within OPERA that are open to sub-Saharan Africa, not as core partners, but whether it be capacity development, whether it be part of our advisory board. You know, I have extended the invitation to someone like from Tunisia, actually, because we need to make sure that, you know, part of the cooperation and community building needs to include the whole of Africa and not just sub-Saharan Africa. At MarCOSIO, I know we're also working closely with Morocco. So, I mean, I think it will come. And I think OPERA is really the first step. And, you know, OPERA 2, I'm sure will be extended. I'm not sure, but it could be another way, you know, it could be part of this long-term roadmap to integrate Northern Africa, which is also really important.
Okay, thank you very much. I think I don't see any more questions incoming. So I want to thank you very much, Lilian and Andrea, for your presentations today and for answering the questions. And I will just be sharing just a few more information before we end the session. So let me go to my presentation, actually. Okay, so as we mentioned before, the presentations from today and a link to the replay of this session will be shared with you through email in the coming days. In the meantime, if you'd like to explore more resources from the Copernicus Marine Service, you can visit the YouTube channel that we have, where you'll find replays of training sessions from the past few years. And each of these training sessions highlights a specific region of the world, a blue economy sector, or a particular application of ocean data. We had a Marine Data for Africa session in March this year, so feel free to actually watch the replay on this playlist whenever you'd like. And I also just wanted to share one last information about the Slido. We actually share a survey with participants from events at each of our events. So if you now go to Slido, you should be able to see this poll that appears on the screen here. And we would be very happy if you would take some time to fill out the survey. This allows us to improve our sessions and really tailor them to the participants' needs. So it's just a matter of a few minutes. And yeah, we'd be really glad if you took the time to fill this out. And I guess the last information I wanted to share is that we'll have another training session on the 16th and 18th of December this year, focusing on water pollution. So during this training session, we'll also have presentations of the tools like Leila presented today with a demonstration of the MyOceanPro viewer, as well as presentations from use cases showcasing how the Copernicus Marine data is used in real life. And we'll also show some Python, QGIS, and R tutorials during the second day to go a bit deeper into the more technical side of things. So the event page for this event will be published soon on the Copernicus Marine Service website. So we invite you to check back in a few days to register to this event. So I guess that's it for today. I can see that someone has raised their hand.
Yeah, it's Marco Clerici from JSC. Hi, Marina.
Hi.
Hi, Marina. Yeah, thanks for organizing this workshop. Unfortunately, Carolina is on sick leave today. She's excused for not being here. I've been following the workshop, very nice, very interesting conclusions, both on what has been done by the consortia in the marine sector in GMS and Africa, CSIR and University of Ghana, but in particular for the perspective of what is coming, and I appreciated a lot the presentation of Lilian on the ARCS program. In this respect, as part of the commission, I would also provide an additional information that the ARCS program covers sub-Saharan Africa, because this is actually the scope of the intervention of the DG INPA, and the Northern Africa is dealt with by DG NIR, a different DG. So that's explained because in some of the interventions there is only sub-Saharan Africa. But as Lilian explained, we have, from a scientific and general point of view, very much interested in working with these countries as well. That's it from my side. Thanks a lot again for the participation and to the presenters for their contribution, and for the one who will be in the final GMS and Africa Forum next week in Cairo. See you soon. Thanks, over to you.
Thank you very much for these precisions. And yeah, I guess it's just time for me to say goodbye. And thank you very much for joining the session today. Thank you to our speakers for their great presentations and for taking the time to answer questions from participants. Once again, you'll receive the replay to the session and a link to the presentations from speakers. You can visit the Copernicus Marine website and ask questions to the user support team or to the AI agent, who knows definitely a lot about everything that Copernicus Marine does. And so thank you once again for joining the session, and have a good rest of the day. Bye.